The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to our introductory online course for Safeti. So before we begin the training, we have some housekeeping rules for this session. So this is the control panel that you see when you enter our session. We welcome you to ask any questions whenever needed. So you can do this in two ways, either verbally at any point in time, or you can type out your questions in the chat window, which we will then answer accordingly. The trainer will answer as many questions as possible, but in the event that we do not have enough time to do that, we will send you the answers after the training. Please note that we will not distribute the recording of this training. There will also be a quiz throughout the training, so in order to click on the poll answers, please remember to exit the full screen mode. So, as it is a full day training, we will have 3 breaks in total, one at 10:30, one at 12, which is the lunch break, and one at 2:30 p.m. So please return to the session on time to ensure that we can resume the training promptly. I will now pass the session to Richard.
Oh, sorry. Sorry, I realized that I muted myself just now. Okay, my name is Richard Lee. I'm the trainer for this introductory online course for Safeti. I'm the technical support engineer for FAST and Safeti, and I've joined the company for 13 years. Yeah, so allow me to introduce you to Todd Yu, the area sales manager. So I pass on to Todd for now. Yeah.
Good morning, ladies and gentlemen. My name is Todd Yu. I'm the area sales manager. I take care of the FAST Safeti and KFX software in Southeast Asia and Oceania. I have 8 years experience in DNVGL digital solutions in different roles. I used to deliver FAST Safeti trainings for basic and advanced trainings in different countries in the past few years. Today, I'm going to assist my colleague Richard in this Safeti introductory online training. Thank you.
Okay, thank you, Todd. So next, we are going to have a round of introduction. We encourage all the participants to introduce yourself by telling us your name, the company you work for, the country you are located in, your job title and responsibility. Yeah, and have you used the FAST and Safeti software before? And what are your expectations in this one-day online course? So I will start with the names alphabetically in the alphabetical order in the name list. So can we start with Mr. Akmal Irfan Khan Rosley?
Hello, everybody. My name is Akmal. I work for MMI Thornton Tomasetti in Western Australia. I am currently a graduate engineer, currently conducting consequence studies for use in safety cases for sites that process oil and gas. I have used FAST before, but for consequence modeling, but it's on a very basic level. And today, I hope to improve my skills and usage of both FAST and Safeti. Thank you.
Thank you, Akmal. So can we move on next to Mr. or Miss Anaswa Chatterjee? Sorry, Mr. or Miss Anaswa Chatterjee. Yeah. Can you unmute yourself?
Hello?
Okay.
Okay, sorry,
I can hear you
realized
now.
I was
Yeah.
muted. Okay. Hi, good morning, everyone. My name is Anuswa Chatterjee. I'm working in Singapore for Singapore Refining Company. I'm a senior process safety engineer that basically focuses on facilitating HAZOPs. I do not have prior knowledge on doing QRAs. And hence don't have hands-on experience on fast and safety. So I hope to be able to understand fast and safety software better and understand the inputs of QRA and how to get a realistic understanding on the outputs from a QRA result. Thank you.
Okay, thank you. So next, can we move on to Mr. or Miss Benoit Joseph?
Good morning, everyone. My name is Benoit Joseph. I'm with Viva Energy here in Victoria, Australia. I'm a senior process safety technologist. I do HAZOPs, LOPAs, and expected to do some sort of consequence modeling. I last used FAST maybe 5 years back, and after that I stopped using because my role didn't require me to do so. So I'm hoping to refresh myself and get a good feel of Safeti so I can get back on and start doing more of these things in the future.
Okay, thank you so much, Joseph. Then we move on to Mr. or Miss Evina Mariam Ishak.
Oh, good morning, everyone. My name is Edwina. So I'm based in Japan, working for Inpex Corporation's oil and gas company. So my title is Senior Process Safety Engineer, looking after all Inpex project all over the world from corporate side. And I have used FAST for consequence modeling for several ongoing Inpex projects, but not very familiar with safety software. So my expectation is to get familiar with Safeti since we are going to use this software for ongoing Inpex project currently. Thank you.
Okay, thank you very much, Ms. Evina. Can we move on to Mr. or Miss Langovan M?
Good morning to all. My name is Ilan Govan. You can call me as Ilan, and I am from India. I work for Technical FMC India Limited as an associate chief engineer, as well as experience with FAST and Safeti. I have hands-on experience in FAST. Safeti, I have a little bit of experience. My aim is to get more understanding of Safeti out of this training. Thank you.
Okay, thank you. Can we move on to Mr. or Miss Emily Kiloran?
Morning, everyone. My name is Emily Kaloran. I work for GHD in Brisbane. I'm a risk advisor, and we do lots of HAZOPs and LOPAs, and just starting to get into QRA a little bit. I've done a fair bit of consequence modeling in FAST before, a tiny bit in Safeti. So my expectations for today is to just get a bit more used to the software and really understand what inputs are required and what the outputs actually mean.
Okay, yeah, thank you very much, Ms. Emily. Please bear with me because from your names, I will not be able to tell whether you are Mr. or Miss. So, so I start with calling out Mr. or Miss, and then followed by your name. So next, can we have Mr. or Miss Shin Hee Young?
Hello, this is Hyun, and I'm from Korea, and I'm working for SK E&C, and I'm a safety engineer, and I don't have that many experience in fast and safety. So I hope this class would be very useful for to get familiar with this program. Thank you.
Thank you. Thank you very much. Next, can we have Miss Cho Hei-mi?
Hello, nice to meet you. My name is Hemi Jo. I'm working for DMVGL, and I'm attending this training to learn for Safeti. And I'm working for not this field, but want you to learn. Thank you.
Sure, no problem with that. Okay, thank you very much. Can we move on to Miss Irene Ting?
Hello. Hello.
Yes, we can hear you.
Yeah. Good morning, everyone. I'm Irene from Malaysia. I'm work for environmental consultancy firm. As environmental consultants, mainly is carry out the EIS study. So my main focus area is to conduct the air quality and 2-hour study. So I have no experience with the Safeti or FAST. So my expectation is I hope I can use it as a tool in my future 2-hour study. Thank you.
Okay, yeah, thank you very much. So next we have Mr. or Miss Jaden Koho. Sorry, how do I pronounce your name correctly? Yeah.
Coelho. Hi,
Coelho.
my name is Jaden Coelho. I am with Advisian here in Perth, Western Australia. I'm a junior safety and risk engineer. At the moment, I'm sort of responsible. Well, I report to my seniors who I do a lot of HAZOP work, a lot of local work, and just sort of in a lot of training at the moment, trying to get up the experience. Haven't had a chance to use safety or FAST yet in a proper environment, just sort of had a bit of a play with the tutorial type stuff, and I'm just expecting to get a bit more understanding of what the capabilities are and to understand how to actually do the modeling work.
Okay. Yeah, thank you so much. Okay, we next move on to Mr. or Miss Ong Ka-jin.
Hi everyone, Kajin here. So I'm actually based in Singapore. I'm working for the Ministry of Manpower, and currently I do look into assessing of the various company safety case submissions. Yeah, so today I'm looking forward to learning more on how to use this software, and yeah, looking forward to have a greater understanding on how to use this.
Okay. Yeah, thank you very much, Mr. Ong. Next, we have Mr. Ken Chen, but Mr. Ken Chen actually asked me to bypass his introduction. So I'll introduce him on his behalf. He's one of our DMVGL colleague working in Kaohsiung, Taiwan. Okay. Let's move on to the next person. We have Mr. Ong Kim Chuan.
Hi, Kim Chuan here. So I'm working with Environmental Resources Management ERM based in Singapore as a principal consultant. So I've been doing risk work for now, HAZOP, hazard, QRAs, etc. So the idea is just to actually better familiarize myself with this software. Thank you.
Okay, thank you, Mr. Ong. Next, we have Mr. Kim Ki-soo.
Hello, my name is Ki-soo Kim, and I'm working for the DMVGL Digital Solutions. I am a sales manager for the FAST and Safeti to Korea and Japan market. And of course, I've used many software of DMVGL many years, and I hope to take a chance to open the Korean course based on today course. Yeah, thank Thank you.
Okay, thank you very much, Mr. Kim. Yeah, it's an honor to have you here. We have next person, Mr. Lim Liang Hong.
Yeah, hi, good morning, everyone. I am Liang Hong. I work with the Ministry of Manpower in Singapore. So basically, my role is similar to Kajin. We do the safety case assessment. And I'm also an adjunct lecturer to National University of Singapore. So I would like to take this opportunity to pick up this software and probably share some of the algorithm or inputs, outputs with my students in NUS. Yeah.
Okay, thank you very much. Okay, then we have Mr. or Miss Maddie Wicks.
Yeah, hi everyone. Good morning. I'm Maddie. I'm a junior process engineer working in Brisbane with Oricon. I've used Fast and Safeti a little, or quite a bit actually, in the last couple of years, but just learnt really through practicing and trial and error. So I'm excited to learn more about the software today and yeah, answer a few questions that I've got. Thanks.
Okay, thank you, Maddie. Next, last but not least, we have Mr. Li Ping.
Hello, morning everyone. This is Li Ping. I'm a senior structural engineer. I'm working for floater offshore operation section in DNVGL in Singapore. Before I have done some structural analysis with accidental loads caused by fire, explosion, ship collision. So I'm quite interested in the background of the load coming from. Today I would like to develop new knowledge area based on the software training. Thanks.
Okay, thank you very much. Okay, so so after one round of introduction, we are now going to explain about this training course. Okay, in our standard DNVGL Fast and Safeti training course, it's a 4-day course. Okay, sometimes it can stretch out to 5 days. So now we have condensed everything to 1 day, but the 4-day course actually includes fast training. But in this, in today's online course, we are just going to have Safeti. So it is assuming that all participants of this course have certain foundation of fast. Okay, but if you do not have any understanding or foundation in fast, that's okay. But what we will do is we actually would, throughout this training course, we would skip the consequence part, and we would focus more on talking about the functions of Safeti and how to get risk results from Safeti. Okay, this training course is designed to cover the main aspects of how to use Safeti within the minimum duration. The minimum duration meaning that within this 1 day. So in this training course, you will learn what Safeti can be used for and the practical aspects of Safeti, how to define event frequency, the windrows or the weather probabilities, the ignition probabilities, the population, how to input all this data into Safeti, and how to set up a study in run rows. We are using run rows to run a study basically. And then how to view all available results in Safeti. What results does Safeti provide? Okay, in this training course, what you would not learn, okay, is the consequence modeling. The consequence modeling is covered in the fast training, so we are going to skip that today. We will also skip pipeline risk modeling and transportation risk modeling because these two parts are quite major part of the training, and it will stretch our training to 2 days instead of 1 day. Okay, then the detailed theory of risk calculation. Yeah, because in order to explain the detailed theory, we are going to spend a lot of time on that. So today's is good. We are more on doing hands-on of the software. So I hope everybody has installed your software, and you may now open your software because very soon we would have to use the software. And then how to run a QRA project. Yeah, this training course is not intended to teach you the fundamentals of the QRA. It's basically just to to let you have a feel on how to use the software. Okay. So regarding the certificate of training, you will be awarded a certificate of training when the following criteria are met. There are two criteria. First, your participation time is more than 90% of the total time, excluding breaks. Okay, that means because GoToWebinar has this function, it will be able to record your time in this webinar. So if we basically this criteria is just to exclude people who log in and then after that log out, and then if this person would like to do this log in log out and assume that he has already attended this training course, we are not going to allow that. Okay. The next criteria is there is a quiz. Okay. Only when you have answered 80% of the quiz questions correctly, then you're eligible for the certificate of training. The quiz questions will come throughout the course, not at the end of the course. So along the way, the quiz question will just pop up, and you have about 20 seconds to answer the quiz question. Don't worry, it's a multiple choice questions. That means we provide you with A, B, C, D. Then you will have to key in your answer. So if a quiz question is not answered, it will be treated as a wrong answer. So no answer is considered as wrong answer. So please key in your answer. Okay. Okay, today's agenda, we will take a look at the overview of Safeti, and then what are the data input requirements of Safeti. So what are the data requirements of Safeti to make Safeti works, to make Safeti run, okay? Once you know this, okay, then you will be able to run Safeti. You'll have a complete Safeti model to run. Okay, and then the study structure, and that means how can you organize your study in different run rows? What are the conditions that you can set for each run row? Okay, then a little bit of risk theory. We still explain a little bit of the risk theory, although we are not going into details of it. Yeah. Okay, and then what are the results that we can expect from Safeti? And last but not least, the help and support. And whenever you have questions about this software, me as the technical support engineer, and also my other colleagues who are also working as technical support engineer, are here to support you in this in helping you to get Safeti running smoothly and successfully. Okay. So now, without further ado, we move on to Safeti overview. Okay, so the introduction is that Safeti software is used mainly for quantitative risk analysis of onshore process, mainly for onshore. We have a different software package for offshore, although sometimes we find that certain users would still attempt to use Safeti for offshore. We have a different software package for offshore, which is known as Safeti Offshore. So today what we are going to learn is the Safeti for onshore, mainly for onshore. Okay, Safeti incorporates FAST and uses the same consequence models for risk modeling. So for those of you who already know FAST, you will now I can tell you that when you are using Safeti, you are using FAST at the same time, because FAST is actually part of Safeti. Now, if you use FAST independently of Safeti, you can what FAST will do for you is just the consequence modeling. But when you use Safeti, FAST, which is part of it, Safeti will also give you consequence results, and it will also give you the risk results. So this is the difference between Safeti and FAST. The applications of Safeti is being used in the following industries, which include oil and gas, petrochemical, pharmaceutical, power plant, academia, transportation and storage, LNG, hydrogen, CO2, insurance, energy, and public sector, governmental and regulatory bodies. Yeah, especially for insurance, the best way for insurance to understand the risk of a petrochemical plant or a refinery is to know the risk level quantified by Safeti, and that will allow the insurance companies to decide on the premium that they are going to charge on the petrochemical companies. Okay, and the application of Safeti is when you're in detailed design stage or when you're in design stage. How can you plan out? How can you plan based on the risk results? How can you plan out such as the facility siting or the layout of the plant, such that the risks to the on-site workers are minimal? Okay, what is the inventory what is the maximum inventory that you can keep inside the plant without having risk to the adjacent facilities or to your neighbors, to the residential areas? Okay, and if in certain countries there's a requirement for safety case preparation, so the Safeti can help you to do the analysis and give you the results that forms the foundation of your safety case. And based on the risk results, how can you better manage your risk? Is the risk of a plant mainly from flammable materials or from toxic materials? So if a plant is handling both flammable and toxic materials, okay, so what is the flammable risk higher or the toxic risk higher? So how can a company tackle the risk? Okay, and then regulatory compliance. Sometimes how can you demonstrate to the regulatory bodies that you have analyzed your risks and you come to the conclusion that the toxic risk is higher than the flammable risk? So your risk management strategy is more on tackling the risk of toxic risks. Okay, and then the operational improvement and optimization. So if you know that the highest risk in your plant is flammable risk, so how can you operate safely without having an accident? And then the chemical transport risk analysis. If I need to transport certain dangerous materials from point A to point B, so along the way, would the material that I carry affect the nearby villages or the nearby towns, or even the traffic on the road? Okay, then above ground buried pipeline QRA. So Safeti has the function of allowing you to analyze the consequence and the risk for buried pipeline. So you can use it for buried pipeline or as well as above ground. Now, pipeline is different from onshore chemical plant because pipeline, it could be in certain countries, the pipeline could be running tens of thousands of kilometers from it could stretch a very long distance. So last but not least, okay, Safeti can also be used as mainly is used for the QRA of hazardous installations or facilities. Okay, the commonly used definition of risk. Sorry, you just have to remember that risk equals to likelihood multiplied by consequence. So that makes the definition of risk. Risk equals to likelihood multiplied by consequence. So we have the risk management workflow that is being shown here in this flow chart. We always start with hazard, that is identify the hazard. Then after that, we try to imagine, okay, if loss of in the event of a loss of containment, okay, then what could happen? Yeah, we try to imagine that we have a leak scenario. Then we evaluate the consequence from this leak. How big is the leak? What is the storage pressure? What is the storage temperature? So when it leaks, is it leaking out gas or liquid? So does it give a jet fire? Does it give a pool fire? So we evaluate the consequences and then we estimate the frequency. So if this happens, how often does it happen? Is it happening once a year or many times a year, 3 times, 4 times, 100 times a year? So we estimate frequency. And this is where our software plays a different role. FAST is being used for evaluating the consequence. And we have another software by the name of leak, which is used to calculate the leak frequencies based on the leak based on historical database. Then we have the Safeti, which does the summation of risk based on the consequences and the frequencies. So we have the risk results. We do an assessment. Is the risk being managed? Has the risk met the risk acceptance criteria? So I believe in a lot of countries there are risk acceptance criteria. If not countries, then for companies, there are risk acceptance criteria being set up to decide, okay, is the risk too high for the company to proceed with the project? If the risk is too high, are there ways that we can mitigate the consequences or reduce the frequency? If there are, so companies or users will actually determine are there ways to mitigate the consequence and to decrease the frequencies. Then after that, we put in the new inputs. How much risk can the mitigation measures achieve? Then the mitigation measures, can it reduce the consequence or reduce the frequency? Then what is the new risk results? The new risk that has included the mitigation measure, has it met the risk acceptance criteria? If it has met the risk acceptance criteria, then we are able to go forward to proceed with the project, to proceed with operating the plant. Okay. So this is the risk management workflow. And the next slide shows you what does each software do. So FAST is used for evaluating the consequence, and Safeti is used to is used to total up the consequence and the frequency to give you the risk results. Okay, what is QRA? So a very simple introduction of QRA. QRA is a risk assessment methodology that allows for numerical estimates of the level of risk associated with a certain activity or series of activities to be estimated and then assessed. Okay, the purpose of QRA, it's usually a legal or a corporate requirement because with a QRA, regulatory bodies or corporates are able to understand the risk of a plant. Okay, and they could understand how much risk are they taking by running the plant. The QRA will supply enough information to help in decision making, such as risk-based design. Okay, do I need to, let's say, for example, is the explosion risk in the plant very high? Do I need to design my on-site buildings to be resistant to explosion? So that is that will depend on the outcome of a QRA study. Okay, and then land use planning. So when I decide to have a plant, can I just put it in the middle of a residential area? Would the risk of this plant, okay, have very high risk to the residential areas around? So what can I do? Should I put a plant at the center of a residential area? That we can get the outcome of the QRA to know whether or not to proceed with locating a plant in the middle of a desert or in the middle of a residential area. Throughout the QRA process, that will allow the analyst to understand the risk. It is important that, let's say, for example, we know that hydrogen sulfide and chlorine are both toxic chemicals. So what if a plant has both toxic chemicals, hydrogen sulfide and chlorine? So is hydrogen sulfide risk higher than the chlorine risk, or is the risk of chlorine higher than the hydrogen sulfide risk? So QRA, by analyzing it properly, we will be able to understand the risk of each hazardous or toxic material. It is a tool to communicate with stakeholders. How can I best tell people who are not trained in science or engineering that the risk of a petrochemical plant or refinery is very high? Yeah, we use numbers because these days we are talking about data-driven society. So numbers are a good benchmark for ranking from largest to smallest, knowing what constitutes the largest risk, what constitutes the least and insignificant risk. Better understanding on priorities, no need to guess, numbers guide better. So the example that I use, like hydrogen sulfide and chlorine, if let's say that the inventory of hydrogen sulfide is less than chlorine, would that make chlorine higher risk than hydrogen sulfide? So what is the risk level of hydrogen sulfide and what is the risk level of chlorine? Okay. From the outcome of the QRA, we are able to devise effective strategy to reduce risk. No need to waste resources and achieve little reduction. Yeah, using back the example of hydrogen sulfide and chlorine again. So today, if I just by engineering judgment, I think that hydrogen sulfide is more dangerous than chlorine, then I invest a lot of resources in reducing the risk of hydrogen sulfide, but probably neglecting the risk of chlorine. Then I could have wasted a lot of money, a lot of resources, a lot of effort. But when the risk of my plant is actually chlorine, then I achieve very little risk reduction. And the risk level, after wasting millions of money, the risk level of my plant has not been reduced because I put it at the wrong place. Okay, so in this slide, you will see what is the typical QRA outputs. Basically, it can be categorized into two categories. One is the individual risk, what we known as the individual risk, and the other risk output of QRA or from Safeti is the societal risk. The societal risk is the risk of a group, that means of the public that is located around the hazardous facility. Okay, the individual risk, there are different terms for individual risk. We have location-specific individual risk, and we have individual risk per annum. Now, these two names are very similar because they both have individual risks in their terms. Okay, but they represent different things. For location-specific individual risk, it's risk level at a certain location. So let's say we have a chemical plant, and these contours, which means these circles that you see, is representing the risk level and the area that is being reached by this risk level. So if I have if let's say this red color circle is representing 1 times 10 to the power of -6 per year risk level, okay, that means the 1 times 10 to the power of -6 per year risk level has reached up to this from, you can see that from the center point, it reached up to a certain distance from the center point. So you would see that, okay, how big an area has the risk impacted, and you can determine if this risk level has reached residential areas or some other sensitive targets, like hospitals, which is considered as a sensitive target. You don't want the hospital to be blown off by a chemical plant. Yeah. So with this, you are able to plan out how should I put the chemical plant in this area, if I put a chemical plant in this area, should I put residential area in around the chemical plant, or how far away should I distance myself? How far away should I distance the residential area from the chemical plant? Yeah, so the location-specific individual risk will help you in deciding that. So that is how the QRA can help you in deciding a distance, okay, a separation distance between a hazardous facility like a chemical plant and a sensitive target like a hospital or a residential area. How should you distance away from the chemical plant? Okay, and then individual risk per annum. The individual risk per annum is the risk of individual when you are located in this location. Okay, how much time do you spend in this location? Okay, that is the IRPA is calculated from the LSIR by multiplying LSIR with a presence factor. A presence factor means that the LSIR is actually assuming that you are located in that location. Sorry, the LSIR shows you. Sorry. Okay, the LSIR shows the risk level of a specific location for 24 hours a day, 7 days a week, and the whole year round. So that is a location-specific individual risk. But if let's say I go to the chemical, I work in the chemical plant, but I work 8 hours a day, and I work 5 days a week. So I do not spend most of the time in the I do not spend all the time in the chemical plant. So there are certain times that I'm away from the chemical plant, and when I'm away from the chemical plant, the risk from the chemical plant doesn't apply to me. The risk of the chemical plant only applies to me when I'm physically located in the chemical plant. So IRPA is equals to LSIR multiplied by the presence factor. So if you are located in a chemical plant for 5 days a week and 8 hours a day, so this is divided by the number of hours in a year. The number of hours in a year would be 24 times 365 days. Okay, so 5 times 8 times the number of weeks. Let's say you work for 52 weeks altogether. Okay, so that is the presence factor, and that will give you the IRPA. Okay, and for IRPA, we also have risk acceptance criteria. Risk acceptance criteria can be represented by this triangle. This triangle, you can see that at the top is an unacceptable region, and at the middle is the allowed region, and also the broadly acceptable region. So if the individual risk is located at the allowed region, it means that, okay, the risk is acceptable, but you should try to continue to reduce the risk if a situation allows. Let's say, for example, if you have the money, you should try to continue to target to reduce the risk to desirable target, to the broadly acceptable region, to the green region here. Now, if the risk level is at the unacceptable region, then it is possibly better to shut down the chemical plant until ways can be found to reduce the risk to allow. So that is the criteria. That is this is the cutoff point that the risk should not be higher than this level. Okay, and then we come to the representation of societal risk. The societal risk is represented by what we call the FN curve. Now, F is the accidents, is the frequency. Okay, the meaning of F is frequency. And N is the number of fatalities. So this is the meaning of FN curve. Okay, so a typical FN curve, according to this ALAP principle, you will divide the region. Okay, you will divide the curve into several regions. Okay, what we have this red color line, this red line. So above this line, this is unacceptable region. So this is unacceptable region. Okay, then we have the region in between the red line and the yellow line. So this is ALAP region. And then we have the region that is below the yellow line, and this is broadly acceptable region. So this is acceptable region. Okay, and the next slide. Now this is an example of the societal risk criteria taken from many sources. Okay, like for example, the black color line shows the UK HSE criteria. It shows that okay, it defines the maximum tolerable region at 10 times 1 times 10 to the power of -2 up to 100. Up to 10,000. Okay, and then you have different criteria from different places. So here is showing all the different colors, and it's a very, I know that it looks very messy, and because different criteria just have different requirements. Okay, the overview of Safeti. We first start with the overview of FAST. So what you see here, the blue color, okay, this is the consequence modeling of FAST. And then we have the green color, which is the component of Safeti. It adds on to the consequence modeling, and it do the calculations based on your event frequency, your windrows, and then subject the consequence outcomes such as toxic, radiation, and explosion to an event tree analysis to calculate the impact onto the population, okay, based on vulnerability criteria. Okay, it gives you the societal risk and the individual risk. Okay, and then the Safeti user interface. We see that we have the run rows that is hidden at the panel here. Okay, so here now, I hope that you have opened the software, so we can move to the software, and I can show you the different parts of the software. So let me change my screen to the software. Okay, so this is the software. What you would see here is okay, this part is the run rows. Okay, it's hidden here, so you need to click on this arrow here in order to expand it. Okay, then this is fast. Okay, we have this standard tabs of model, weather, parameters, materials, map, and risk. Okay, this is fast. Whereas Safeti would have what we call the super tabs. We have the input, the run row grid, the combinations, and the results. These 4 tabs are known as the super tabs. Okay, apart from that, it's how can I? Yeah. Okay. Yeah. Then we have the this part that is identical to fast. This is and then we have the output screen. So this is the interface of Safeti. And we have a mode that is, okay, fast has the discharge and the consequence. Safeti has the risk. So what's additional is the risk. Okay, and then for the results part, okay, the fast has consequence data, reports, graphs, and GIS. Then for Safeti, there is one thing additional that is known as the risk. This will give you the risk results generated by Safeti. Okay, so let's go back to the PowerPoint slides. Okay, Safeti data input. So in order for Safeti to work, in order for the model to run, it will require the following data inputs. Okay, first is the release cases and the frequencies. What are release cases? Release cases are basically the models or the scenarios that you have built. Okay, and then frequencies we refer to the leak frequencies. Okay, the leak frequencies of each scenario. Then the weather probabilities. The weather probabilities, basically this is the Windows data. And then Safeti will need population data, okay, to give you societal risk results. Without population, it will only give you individual risks. Okay, but initial sources is initial sources. Okay, you will need to define the initial sources around the map so that the model can successfully work. Then we have risk ranking points, and it's optional to add the plant boundary. Now the plant boundary, it allows you to determine, it makes it very clear, is a certain risk level out of the plant boundary or within the plant boundary. Okay, so the case study in this training course, we are going to use a case study. This facility is a refinery that incorporates some chemical production facilities. A range of process units exist on the facility. For the purpose of the exercises, the units and a selection of hazards within them are of interest to us. We shall consider a theoretical COMA regulated process plant in the UK that deals with both toxic and flammable materials. The risk assessment will consider flammable and toxic effects from a range of materials which are present in the site. The off-site and on-site emission sources will be considered. The off-site and on-site population sources will be considered. Individual and societal risk measures will be assessed. So this lays down the scope of our case study. We need to define the off-site and on-site emission sources. We also need to put in the population around the chemical plant. Okay, so we have a picture of this chemical plant, and this chemical plant, is made up of different process units. Each of these process units is being represented by this NHT, CCR, this kind of short form. We do not need to go into detail of this short form process units. Okay, it's if you open the case study, the exercise study file, you will be able to see that the scenarios have already been inserted for you. Okay, the process unit abbreviation are being explained here. Like for example, the HCU is hydrocracker unit, and the HPU is hydrogen production unit, and the SRU is sulfur recovery unit. Okay, so and the individual risk criteria that we are going to use for this case study is represented by this picture here. We have the unacceptable region cut off at 1 × 10⁻³ per year for workers. Now this is for workers, and for the public, okay, the criteria is more strict. Okay, for the individual risk of the public, the individual risk shall not exceed 1 × 10⁻⁻⁴. Okay, so for workers it's 1 × 10⁻⁻�3, and for public is 1 × 10⁻⁻⁴. And then we have, okay, the following release cases have been defined in Safeti Training starting point.psux file. Okay, so right now, let's open this file. Okay, I'm switching my screen to the software. All right, I would like you to click on File and then Open, and then go and look for our handouts. Okay, so you should be able to see that you have 0 up to 8 Safeti Training files. Okay, and I would like you to open Safeti Training starting point.psux. So let's do that. Let's open the file, and then you will be able to see that there are a lot of study folders. Here you have HCU, HPU, HSRU, ISOM, CCR, and HD, all these different process units. And if you expand the study folders, you will be able to see the, let's say when I expand the HCU, I'm able to see the no-name feed line, and we have a small, medium, large scenarios. So this is the whole size, because small, medium, and large are referring to the whole size. Then these are the scenarios. Okay, and then the first exercise that we are going to do is to key in the event frequencies. So how can what is the instruction for keying in the event frequency? So let's take a look at the PowerPoint presentation slides. Now, before I go on with the instruction to key in the event frequencies, allow me to just make a simple explanation of where the event frequencies are coming from. You can see under the references here that the event frequencies are taken from UK failure rates. The website is being given here. Then it's also possible to extract the release frequencies from IOGP report. The IOGP report has a report number of 434-01. Then also we can get the frequencies, the leak frequencies from BEVI 3.2 or 3.3. Okay, so these are the different sources of the leak frequencies. Okay, then the next thing is, we are going to do this exercise. That is to define the event frequencies in Safeti, to key in the small with 0.032 per year, and then the medium with 2.95 times 10 to the power of -3, and then large 8.26 times 10 to the power of -4. Then for catastrophic rupture scenario, the event frequency would be 1.16 times 10 to the power of -6. For line rupture, it's 5.64 times 10 to the power of -4, and the relief valve is 0.06462. Okay, so now if I change the screen to the software, okay, so the thing is, okay, I have a lot of scenarios, and am I going to key in the scenarios one by one? So this is going to take some time. So how can we do this in an effective way? So what I would do is first we click on the study folder. Okay, make sure that the mouse highlight is at the study folder. Then we click on this grid tab. Okay, and then unlock this. Right, and then click on the drop-down list. Click on the drop-down list and choose leak. So by this way, we will be able to, and then I would choose to close the output window, this output window, in order to make this screen larger so that I can see clearer. Okay, so we have, so what we have here is a list. Okay, a list of the scenarios. The scenarios are differentiated by the name small, medium, and large, and you have the full path. So this will direct you to because we have repeating names of scenarios like small, medium, and large is repeating. then but the full path will be able to direct you that these scenarios belong to the HCU process unit or the HPU process unit. Okay, the next thing that we should do is to move to click on this arrow in order to move to the right hand side. And look for the event frequency. Okay. Okay, so now, okay, we will need to move the event frequency column to the left-hand side because we are not able to, we should put the event frequency column next to the name so that we can see in one screen, okay, that this event frequency is for this scenario. So right now we have to keep scrolling and that is not convenient. So we just, this grid, okay, works a bit like Excel. So you can actually move the column as close possible to the scenario. So we move the event frequency, okay, and place it next to the scenario. Okay, then in this case, we would be able to key in the event frequencies very quickly. So I'm going to key in 0.032 and then 2.95 E minus 3 and keep repeating. Okay, and you can also copy and paste. So what you can do is highlight these 3 event frequencies together, okay, and then press Ctrl C to copy. And then after that, move on to the next row and then paste. So this will allow you to key in the event frequencies very quickly. So this is the practical aspect of the software. It allows when you have many scenarios and you need to spend time keying in the data. So the grid view will actually allow you to list down all your scenarios, and you will be able to work like Excel to key in the data very quickly without wasting too much time opening each of the scenario. Okay. So we have done this for leak, okay? But then we will also need to open catastrophic rupture scenarios. So let's take a look at, let's find catastrophic rupture in the drop-down list. So click on catastrophic rupture. Okay, we have 3 scenarios which are catastrophic rupture. And we will need to input the same event frequency for catastrophic rupture, and that is 1.16 times 10 to the power of minus 6. So first, so now what I would like to do is to move the event frequency column to the left-hand side, as left as possible, as closely as possible to the scenarios. Seems like I lost it.
The very first column is the event frequency. You have moved to the entire left.
Yeah, I think I lost the event frequency column, so I'm trying to look for it.
No, it's the first column is the event frequency.
Oh, sorry about that. Okay, yeah, okay.
Yeah. I suggest you repeat.
Okay.
Yeah, Richard.
Yeah.
Some of our participants couldn't manage to follow your steps. Maybe could you repeat from the grid?
Okay, from the grid.
Yeah,
Okay,
from the beginning.
sure.
Yes, yes.
All right. So I will just okay, close this first. Okay. So the first thing to do is to move your mouse to this study folder. Okay. So and then click once at the study folder and make sure that the mouse highlight meaning that this blue bar, okay, is at the study folder. Yeah, it makes a difference if your mouse highlight is at the study folder and at the folder that is below and at this green icon here and at this. So it makes a difference. So make sure that your mouse highlight is at the study folder. So the next thing is, okay, click on the grid tab. Now, if you cannot see the grid tab, so please come to the view tab at the top here. Okay, click on the view tab and then click on this views. The second icon from the left, all right? And then you should be able to, okay, because I have the grid here, so if I close it, all right? So let's go to view again, the view tab, and then click on views.
Grid is already on the ribbon.
Oh, sorry.
Yes.
Yeah, sorry about that. Yeah. Sorry, the grid is here. Sorry about that. Okay. So click on this grid. Then you'll be able to see the grid here. Okay. Then unlock this. All right. Unlock this. Then just now, what I did was I clicked on the drop-down list and choose leak. Okay. This is a bit of a fast basics because of small, medium, large here. All these are leak scenarios. Under fast, okay, under this equipment, which we call no-name fit line, okay, there are different scenario types, okay. The scenario types are include catastrophic rupture, leak, and then fixed duration release, short pipe, time varying leak, and then there is time varying short pipe release and user defined source. So based on the different scenario type, in the drop-down list here, when I choose leak, what the grid will do is that it will help me to list down all the leak scenarios that are under this study tree. So with all these scenarios being listed down, I will be able to input my event frequency very quickly. Okay. So this grid view also works a bit like Excel. So you are able to move this event frequency column from the very right-hand side to the left-hand side. Try to move it as close possible to your full path and name, because these two columns are what we need to identify the scenario. So we need to know that this is a small leak scenario for no-name fit line, so that I will know that to key in 0.032 for this scenario. And then for medium, I will key in 0.00295. And for large, I will key in 8.26 E minus 4. Okay, up to this part, has anybody any questions? All right. Then if you have already key in all the event frequencies for small, medium, and large scenarios, the next thing is to choose catastrophic rupture. Catastrophic rupture scenario is just above leak. Okay. So click on catastrophic rupture and then key in the event frequency. Just to speed things up a bit, we have the same event frequency for the same type of scenarios. In actual QRA, it may not be the case. So just take note. Okay, so I've keyed in the event frequency for catastrophic rupture. Then I will move on to the next scenario type, that is line rupture. So I will start from the beginning again to see where I can look for line rupture.
It's short pipe here.
Oh, short pipe. Okay. Yeah, short pipe. Short pipe. So line rupture is under short pipe. Okay. So under short pipe, we also have relief valve. So just take note, because we have a different event frequency for line rupture and relief valve. Okay, again, we are going to minimize the nodes, and I will move the event frequency.
Hi, excuse me. Hi, I
Yes.
have a question. I'm sorry. For leak, I had selected leak, but I couldn't capture the values in time for the event frequency. If you could just go back and quickly show that, or if you.
Yeah, sure.
Yeah.
Okay. Okay, so for small is 0.032. For medium, it's 2.95 E minus 3. And then for large is 8.26 E minus 4.
Okay, just a second. So you have to select small to get the leak, the table to show up, because when I select small, it doesn't show up anything.
No, it's not selecting small. It's selecting leak.
Yeah, so it has
Okay.
to be selected at the study level, right?
Yes, and it has to be at the study level.
Okay. All right. Let me see. For small.
So
Okay,
at the
so
drop down,
I can move the column across, right, to make it easier for
Yes.
myself to view.
Yes, correct.
Okay. Okay, so for small, it's 0.032.
Yeah, that's right.
And could you just show how you copied it across?
Okay. So what you can do is highlight this tree. Okay, how do I highlight is basically click once at 0.032.
Okay.
Then move my mouse down to the large scenario, and then press Shift and left click at the same time. Yeah.
Okay.
Press and hold. Sorry. Press Shift and hold your left click.
Okay.
Yeah, and then press Control C. Press and hold Control C. Yeah.
Okay.
Okay. Then the next thing is you move on to the next row.
Mm-hmm.
And then press Control V.
Yep. Okay. And you repeat that, right?
Yeah.
You can also select all of the column rows and copy and paste at one time.
Okay.
Yeah, to select all the rows, that means you scroll down all the way to the end.
Yeah.
Okay, and then
Control
press
V.
Shift and left click at the same time, and then Control V.
Then it will paste all of the values to all rows. And maybe you can demonstrate column chooser as well, Richard.
Column chooser.
So if you right click on the header of the table, yeah, open column chooser. Yeah. So by default, you can see here
okay, I see.
for leak scenario, there is a there are too many columns in that grid. Sometimes you only want to look at a few columns. Like what we are doing now is we want to define the event frequency for the leak scenarios. What we can do is here, when you open column chooser, you will be able to see all of the fields in that grid. Richard, if you go, so here you can see there are two boxes. If you go to the right-hand side, if you click on one of them, then you press Ctrl A to select all of them. Then you can move all of them to the left-hand side. Then you can select the fields you need and move them to the right-hand side. In that case, yeah, Richard, you can select.
So you have a A to Z. You have an A to Z sort. Okay, so you can sort everything according to alphabetical order. Then the next thing is, let's say I need the full path. Then I need the name, that is N. Okay, and then I need the event frequency, that is E. So I just want these 3 columns to appear in the grid only. Oops. Yeah. So it will take a while, okay? But now I can have a clean grid view that is only consists of a full path, name, and the event frequency.
Okay.
Yeah.
Got it.
So this will filter off the rest of the information that you do not need to see. Okay. So is that all right? So to move on, because we are running short of time. So what I would do is, okay, we have prepared the next step for you. That is, if you would go to File, the File tab, and then click on Open. So go and look for your handouts. Okay, just now we start with a Safeti training starting point. So now if we click on number 1, Safeti training event frequency, this would have the event frequency fill up for us. Okay. So we provide, in this training, we provide some hands-on session for you to practice the software a little bit, okay? But because of the time constraint, once you get the idea of how to fill in the event frequency using the grid view, using the column chooser, now we can move on, okay, to a completed event, a completed model. A model that has been filled in with event frequency values. All right. So once we have opened this model, and if we click on one of the scenario, we will realize that, and we click on the risk tab. So now the event frequency has been filled in. Okay. If we are not using the grid view, this is how we have to open each scenario and key in the event frequency. So this will be troublesome. Yeah, you have to double click at the scenario and then click at the risk tab and then key in the event frequency, close the window, move on to the next scenario and do the same. So this is too many repetitive actions. Okay, let's move on. I'll change my screen to the PowerPoint presentation slide. Okay, now is we are going to insert the weather data. So what we have here is the wind rows. Okay, the wind rows would tell us some basic information such as the predominant wind direction. So in this wind rows, we are able to see that the predominant wind direction is blowing from the south to the north. Okay, how we look at this bar is, if let's say we look at this bar, the wind is blowing from the south to north. So imagine that you are standing in the middle, and this is where the wind is blowing from. Okay, if it's blowing from the north to south, blowing from east to west. So this is how we look at wind rows. Then this wind rows is comprehensive in the sense that because it provides you with percentage lines, okay, telling you the frequency, okay, of each wind direction, and the wind speed is being represented by different colors. So I would say that this is a comprehensive wind rows, but in actual case, a lot of wind rows doesn't provide such detailed information. Okay. Just by providing the wind rows alone, we would not be able to extract all the frequency data for the wind speed, for the wind direction from the wind rows alone. Very often we would need to have the detail, the raw data, the raw data from the weather station. Okay, so the weather probabilities are defined for each weather folder in the study tree. Safeti allows 4, 8, 12, 16, or 18 weather directions to be specified. The matrix of the weather category and direction allows specification of relative physical condition probability, relative directional probability. The values can be normalized automatically. It means that doesn't matter if you key in 0.06 or 6% here. It's okay that you key in the 6 or you key in the 0.06. Later, it will normalize. Okay. The 0 or 360 degrees represents wind from north. So here we start with 0 degree, and this is 45 degrees. Then this is 90 degrees. Then this is 135 degrees. And this is 180 degrees. This is 225 degrees. 270 degrees. 315 degrees. All right. So we are going to do another exercise that is defining the weather categories. So in our model, we already have category 5D, category 2B, 8 wind directions under the day weather folder. And under the night weather folder, we have category 1.5F and category 1.5D. Okay, so I hope you understand what is category 5D. 5D means that the wind speed is 5 meters per second and the particle stability is category D. So this is a basic, this is also another basic of FAST, which I just simply introduce here. Okay, then we move on to the software. Okay, so at this screen, I would like you to click on the weather tab. Okay, so here we have a category 2B, 5D, 1.5F, 1.5D. What we need to do is to, okay, first click at the top. Okay, click at the top. You need to make sure that the mouse highlight is at the top level. Then the next thing is look under this insert. Okay, and there's a weather folder. So click on the weather folder. All right. And there is a new weather folder being inserted here with a red exclamation mark. The first thing that we do is to rename the weather folder. We rename the weather folder by clicking rename here. Okay, so click on the rename and then we name this weather folder to night weather. Okay, once we have renamed it, then we drag category 1.5D and category 1.5F down to the night weather folder. So we drag this 1.5D to night weather, and we also drag 1.5F to the night weather folder. And then we expand the night weather folder. We realize that there are 3 weather categories. So let's delete the first one. You can either click delete here, or you can press on the delete button on your keyboard. Okay, so now we have sorted weather category 2B and 5D to day weather and 1.5D and 1.5F to night weather. Okay, so this exercise, the objective is to split the weather folder into day weather and night weather. Okay, let's carry on. Then we've renamed this weather folder to day weather. Okay, next is let's take a look at the PowerPoint presentation slides. Okay, we have the probability numbers here. Okay, so for category 2B, what is the probability for wind blowing from the north? And then for wind blowing from northeast. Okay, it's all given in these two tables. Okay. Then we go back to the screen. Then we go back to the software. All right. Now let's double click at the day weather. We double click at the day weather, and then the number of directions is 8. 8 wind directions. Okay, you can keep the box checked for normalized before calculations, and then we scroll down. We scroll down to this part, where this is the part that we key in our probability numbers. Okay. So you can just click at this box, okay, and then type 10. Actually, you can just click and type. You do not have to double click and then highlight. Do not have to. So you can just click and then key in.
Richard, we have 5 minutes next break time.
Okay. All right, then let's pause for break. We have 5 minutes break. Please come back at 10:31. 10:31.
No, Richard, we are having our break at 10:30. So it's a 15 minutes break. Yeah.
15 minutes break. Okay. So I have 4 minutes more. Okay. So let's continue. Sorry. Okay. Okay. For the degree of 157.5 to 202.5, the number is 4. Then it's 4, 6, 9. So you have 10, 7, 6, 5, 4, 4, 6, 9. Then the next one is 3, 3, 3, 3, 6, 9, 12, 10. Okay, so this number is repeated for night weather. So we have a 10, 7, 6, 5, 4, 4, 6, 9, then 3, 3, 3, 3, 6, 9, 12, 10. So this number is repeated for night weather. Okay, if you just click on OK and then double click at night weather. Okay, night weather, we take a look at the number of directions. It's 16, so let us change to 8 directions, and then we scroll down. Okay, you will see that it's being grayed out, but don't worry, you can click and then type. Okay. You may be mistaken that, okay, because it's grayed out, then you are not able to type, but actually you can just click and type, no problem. So I will just repeat the numbers from above, from day weather. So it's 10, 6, 10, 7, 6, 5, 4, 4, 6, 9. Then the second row, is 3333 69 12 10. Oops, sorry, 3333 69 12 10. Okay, and then you can click on OK. All right, just a very quick one, because we see that the night weather, the red bubble is still here. So what I will do is uncheck the box for normalize before calculations. Click OK. Then double click again. Check the box for normalize before calculations and click OK. Now the red bubble will be gone. So it's a very minor bug. Yeah, but it's a small trick to get rid of the bug. Okay, so it's 10:30 now. So let's take a break.
Sorry, on my Safeti training globe, there is an exclamation mark. Is there any reason I've done something wrong? Is that why it is?
Yeah, you have a red exclamation mark, right?
Yes.
Okay. Is it at the night weather or at the day weather?
Oh, it's not. It's at the globe right at the top on next to Safeti training. Yeah.
Right
Yeah.
at the top. Okay, can you please go to map tab and check the raster image set? Is the red exclamation mark showing there?
My tab, when I click on safety training, it only shows me the weather. So I go to a different tab.
Yeah, the map tab. Yeah, I've just checked mine and it's got the same.
Okay, I'm in there now. Raster image, yeah, those have got the exclamation mark as well.
Yeah, okay. So just an explanation. For the rest of you, you can go for your break. And for those who want to stay on and listen, yeah, you are welcome to do so as well. Okay, you double click at the area around the site.
Okay.
Right. So if you see that the path is actually being boxed in red.
Yeah.
Is that correct? Okay. Yeah. So that's because the software only save the path to look for the map. So when you open our file, okay, it shows you this exactly the same path. Okay, but for your case, because it's in your laptop, you do not save the map at this location. So what you should do is to click on the pencil icon, and go and look for your map. It should be part of the handout. Okay, I save my handout here. Okay, Safeti introduction. Yeah, you should be able to find a folder called map images, and you have two maps under this map images folder. It's area around the site and local site map. So you just direct the software to look for the map. Okay. Once you click on open, okay, so the path will automatically be updated.
Okay.
And then when you click OK, then the red exclamation mark will be gone. Okay, do you manage to get it?
I don't have the image. I'm looking.
Okay, the handout are.
The images were sent with the handouts.
Yeah.
Okay.
Yeah, we sent out the handouts yesterday, so you should have all of those files and the maps.
Yeah, the maps, it's under it's under a folder called map images. So look for the map images in the handout. You should be able to find the two maps.
Let me have a look. I did not. I did not receive the handouts. Could you just double check if that email was sent to me with the attached files?
Okay, just now, Todd also sent out a link for the handout. Can you look for a message that's been sent at 9:59 a.m.? The handout can be downloaded from. Yeah, you click on the link. Yeah.
Hi, I accessed the email that Todd sent, and I don't see a map under the downloads, under the handout exercise files. There's no map.
Yeah, even on the link, there was no map. All of the files are there except the map.
Let me see here. Let me just take a look.
In the download link, maps are given in a separate folder, not part of this Safeti folder.
Okay.
Actually, I sent a message in the chat box a few minutes ago. So if you click on the link, you should be able to see the files, which include the handouts, the map, and the PSUX files for Safeti.
So which map? There are two pictures. Which one? Around the site or the local site map? Which one should I select?
In Safeti, in Safeti, you can see there are two maps. So you just link one of them. Sorry, you just link them respectively. So for the area around the site, you link to the map area around the site. For local site map, you link to local site map.
Okay, fair enough. Thank you.
Hi, I had one more question. On the weathers tab, there is still on the night weather, I see a bug, a red exclamation mark. Hello?
No, you can go to, you can double click on the night weathers folder. You can click on normalize.
Normalize before calculations?
Yes, you click on it,
and
then you click on it again to make sure it's selected.
Okay.
Then if you click on OK, it should be okay for you. So this is the minor defect in Safeti. Yeah.
All right, I got rid of that too. Okay, I managed to bring the maps in. Thank you very much.
Yeah, great.
Okay, so we're on our break till 10:45, right?
Yes, yes.
Okay, thank you so much. Okay.
Richard?
Yes.
This is Ilan. I have one minor question. This night weather, why it is in a gray color instead of day weather, which is on black?
Okay, because it's not selected by the run row.
Okay.
Yeah.
Thank you.
Okay, it's 10:45. Can I just have an indication? Is everybody back from the break?
This is Ilan. I mean,
All right. Okay. I just want to explain certain things regarding the flow of the training. Because today we have a very tight schedule. We need to complete this training within today itself. So we actually have prepared the models that has been completed. Each step that has been completed. So you can, if you cannot catch up, you can always go and open the model that shows the next step. Okay, the model that shows the next step would have completed, let's say, the weather probabilities input for you. Okay, so the exercise is meant for you to just have some practice, have some hands-on, to have an idea of what is the data required and how you can key into the software. Unfortunately, we are not able to wait for you to finish everything nicely. So because we have to keep moving on. So in this case, I will have to ask you to I will have to ask you to move on. So what we can do now is let's go and open the next the model of the next step. So this one is number 1, Safeti training event frequency. So let's open number 2, Safeti training weather. Okay, so this one would have put in the weather probabilities nicely for you. Okay. The next step would be we move on to insert the population data. And when we are inserting the population data, it will be very difficult because the geometry shape is very difficult to draw. So if I were to wait for you to complete the whole thing, it will take, it can really take up to 1 day. So the population data map is quite complex. So I hope you will just get to know that it's just for your hands-on practice. You can just finish halfway and then move on. All right. So let me share the screen of the PowerPoint presentation slide. Okay, we are now at the population data. Okay, so the population data is used for societal risk calculation. If your aim is just to generate the individual risk contours, okay, you do not need the population data. But if you need to generate the FN curve, population data is required. So populations are entered on the risk tab of the study tree in the population folder. So first of all is you click on the risk tab of the software. Then you look under the population folder. Okay. Categories can be used for different population. So when you insert the population, one thing that you need to do is that first of all you will need to separate whether they are on-site workers or they are off-site population. Or are they the off-site public population? So we have provided a few categories, like for example, city population, residential population, industrial population, urban population, semi-urban, rural, commercial, other operator. So of all these populations, you will see that a lot of them are basically the public, the off-site public, okay? And this operator refers to your on-site operators or your other on-site workers. You can also add in other categories such as admin or such as maintenance workers. Okay. So apart from the population category, you will also need to define the population. Okay, the density is calculated automatically. It is using the population that you insert divide by the area that you draw on the map. So you have the map, and we would draw on the map what is the population area. So the software will calculate the population over the area to give you the density. Okay, and then you will need to define the time that the population spend indoor or outdoor. So this is just an assumption, like say for example, in this case, 0.75. This is the fraction of the population indoors. That means 75% of the time the population is indoor, or all the time 75% of the population are indoor. It can also be, that means 25% of the time the population are outdoor, all the population are outdoor, or all the time 25% of the population are outdoor. 25% of the time, 25% of the population are outdoor all the time. Something like that. So it can be interpreted both ways. Okay, for the population data, when you insert on the map, a variety of shapes can be inserted, such as you can insert the population point, you can insert a rectangle, and you can also insert a polygon. Then choose a category for each population in the software. You can change the color and pattern for the category, and adding or renaming or deleting the categories. So the impact of different categories is that Safeti will calculate the societal risk results separately for different categories and report the category PLL for each category. So this is the impact of the categories. That means Safeti will report the societal risk results for each category and the PLL for each category as well. Okay. So then the next thing is we are going to define on-site population. So we start with on-site population first, okay? And then here you can see in the map that we are drawing out the utilities plant, which is a rectangle. Then the offices, which is also a rectangle. Then the process area, which is a polygon. And then the control room. Please do not miss out the control room. The control room is a population point. Okay. So to draw out this, okay, I'm not expecting you to draw very nicely or very accurately. Okay. So this will take some time, but we are not expected to spend too much time on this. So I will demonstrate on how you can draw this population, on how you can define the population on the map. The next thing is, okay, the data to be inserted for all these different population categories are given in this table. And please take note that the population should be separated according to daytime and also nighttime. Okay, then you have how many people, and then what is the fraction indoor. Okay. So if you can open your hands up, okay, if you can open your hands out for this slide in another screen, okay, so then you can refer to this screen and insert the data. I'm going to switch over to the software now. Okay. All right. So now at the software, please click at the risk tab. Okay, so please click at the risk tab. Then look for a population folder that has been grayed out. There is a gray color. Okay, you have this population folder. All right. Now, before that, I need you to make sure that you are able to see the map. Okay. So can you click at the map tab and make sure that the area around the site under raster image set folder, okay, there is no red exclamation mark around it. If you have an exclamation mark, then you will need to look for the correct map. Okay, so let's double click at the area around the site. Okay, now if you find that your path is being boxed in red, you will need to change the path in order for the software to locate your map. Now this path is it works for my computer, but not your computer, because you may save your map at a different location. And so this software doesn't save your map, it saves the path to look for your map. So please click on the pencil, okay? And then you will need to go and browse and look for your map. There are two maps altogether. One is called area around the site, and then another one is called the local site map. So make sure that you are able to see these two maps, right? Now the training on how to insert the map into the software is being included in the fast training. So when we are at this Safeti training, actually we assume that you have some background or you have some foundation in fast, you know how to insert the map in the software. Okay, so if I click at the GIS input, okay, I will be able to see the map. All right. Now we will need the map because we need to draw out the area of the population in the map. So let's go back to the risk tab. Okay, and then scroll down and right-click at the population folder, and then choose Insert. So you have population point, population polygon, population rectangle, building population. Okay, so we will take some time to practice, but I do not expect you to complete the whole exercise because it's simply too time consuming. Okay, so you can just you can either look at how you can look at my demo, or you can also practice on your own machine. So the first thing that I would do is to insert the population for the utilities plan, and that is a population rectangle. So I click on the population rectangle, and now the instruction is to draw the rectangle on the map. So I just scroll in to zoom into the map for a larger appearance. Okay, and then I just click on one side and then I click on the other side. Then I pull out a rectangle. Now please note that you do not need to be accurate, okay? You just have to draw as long as it has the shape and it roughly covers the area of the utilities plan, that's okay. Okay, so I've drawn this population rectangle for utilities plan. Then I will need to rename this population rectangle to utilities plan. Okay, and then I will need to double click on the utilities plan so that in this pop-up window, I can insert the relevant information. Okay, so for this utilities plan, the population category is operators. So the first one, operators, the category is operators. Then the next thing is key in the population. So daytime population is 350. We will duplicate this utilities plan population for nighttime later on. What we will do is do for daytime first. Okay, we should key in 350 here, and then if you click,
we're on the utilities plan. The population is 20.
Oh, sorry. Yeah, you are right. Sorry for that. Okay, yeah, the population for utilities plant is 20, correct. And you would see that the density is being updated automatically. Okay, so after keying in the population, which is 20 people, then click on the general risk tab to key in the fraction indoors. So the fraction indoors for utilities plant is 0.5. And then click OK to close the window. Okay, so we have inserted the population data for utilities plant for daytime. We will deal with nighttime later on. Okay, let's carry on with the offices. Okay, offices is located at this area here. So I will right click at the populations folder, choose insert, then I will choose population rectangle again. Okay, then the instruction on the map is draw rectangle on the map or hold control to copy existing geometry. So what I will do is I'll click at this, look, oops. Oh, it seems like I have to redo again because there is some error. Okay, right click, insert, population rectangle. So I will click at this point, and then at this point, and then drag the rectangle over.
Is there any reason why my map is highly pixelated? Do I need to change some setting?
Okay. Okay, if you if you look at this panel here, the legend, look at the legend. Okay, is your local site map below area around the site? So if your local site map is below the area around the site, can you please drag it up? You can drag it up by clicking once at it and then drag it up.
Okay, yeah, it's better now. It's cleared up.
Okay, so now I close my output window. I've closed my output window to make the map bigger. So now I have drawn out a map for the offices. Okay, let's rename it. Okay, the rename button is located under the home tab. Okay, so make sure that your mouse highlight is at the population rectangle and then click on rename. Then you will be able to rename it to offices and then double click. Now the population for offices is 420 and the population category is admin. So click on the drop down list and choose admin. Okay, the density will be automatically be updated. And then click on the general risk. Okay, so the fraction of population index for societal risk is 0.9. So that's the same. Okay, then click OK. All right, then the next thing is we are going to insert the population for control room. I would prefer to do control room first before doing the process area. So again, I click on the populations, right click, insert, and this time around I will choose a population point. Okay, where is the control room located? The control room is located, if you would see that there's a long pipeline at here, and then there are two buildings below here. Then the control room is below these two buildings. It's here, okay? Oh, once I do the highlight, I'll be kicked out. The map will be zoomed out. So it's located here. So it's a point. So the next thing is rename the population point to control room. double click, and in the pop-up dialog window, which is this window, insert the population. The population for control room is 15 people. And the category is process control. Then click on the general risk tab. The fraction of indoor is 1. Click OK. And lastly, I would do for process area. So now I'm going to click on the populations folder again, right click, insert. This time around, I will choose population polygon. Okay, so I just have to draw from here to here to here. Okay, the instruction on the map is draw polygon on the map, double click to end. So when I'm about to end, so I just have to double click. And then now I have a polygon shape. Okay, so now rename it to process area. And then double click and define the population, 350 people. The category is operators. And the fraction of indoor is 0.5. Now click OK. Okay, so now we have defined the on-site population for daytime. And we are going to duplicate. That means we are going to copy and paste all these utilities plant, offices, control room, process area for nighttime. So now let's click at the utilities plant. Okay, then you have the clipboard, which has the copy and cut here. Okay, so first click on the copy. So it will copy the utilities plant. Then click at the population, and you will see that the paste button is being activated. So when you have moved the mouse highlight to the populations, then you will be able to paste, and it will appear as utilities plant bracket 1. Okay. And then do the same for offices. Copy. Then click at populations level and then paste. Okay. Do the same for control room. And do the same for process area. So now we have duplicated for utilities plant, for offices, for control room, and process area. So we are going to rename all this to separate them daytime and nighttime. So I will add a underscore day or night at the end of the population name. So let's say, for example, utilities plant. Now I'm going to rename it again. I'm going to add a underscore day at the back. So same for offices. I'm going to rename it. Click on rename and type underscore day at the back. Okay, another shortcut key to rename is to press on F2 on your keyboard. F2 on your keyboard. Okay. So we are going to rename all these utilities plant, offices, control room, process area to nighttime, and we are going to double click into them and then change the population and fraction indoors in all these population categories.
Sorry, I just missed how to copy them down.
Okay. So first of all, you select which one, which population you would like to copy. So let's say I would like to copy utilities plant. Okay, so I click on utilities plant. Then there is a clipboard here.
Yeah.
So there's a copy. So click on the copy.
Yep.
All right. Then you move up to one level. You move up one level. That is going up to the populations folder here, and then click on paste.
Ah, okay.
Yeah.
Yeah.
You can also
that just copy the.
You can also use shortcuts. So when you use Office, for example, you use Microsoft Word, you use Ctrl+C, Ctrl+V to copy and paste. Similarly, you can also use Ctrl+C to select the nodes. Then you can select the populations folder and use Ctrl+V to paste it.
Yeah. So Ctrl+C and Ctrl+V works in this software as well. Okay.
Thank you.
So now I'm going to rename this utilities plan to nighttime. So I will just I press F2 on my keyboard to rename, and I give it an underscore and then type night, and then offices F2 underscore night, control room F2, remove the bracket 1 underscore night, process area, remove the 1 underscore night. Okay. The next thing is to double click at the utilities plan night. Okay, and to change the population in it. So the population for utilities plan for nighttime is 10%. And okay, the population category is still the same. And for the fraction indoor, it is now 0.9. So click on OK.
Yeah, you can also use grid here, which is easier.
Okay. So to use grid, that is to click on grid. Okay. Then click on populations. Okay. Click on grid. That's the first thing, and then check if this is locked. If it's locked, then unlock it by clicking on it. Then click on populations folder. Okay, then click on the drop-down list, and then choose population. So now I've just done it for utilities plan. The next thing is to do for offices. It's 35. There's something wrong. Yes, I can see there is something wrong. Okay, so let's correct everything from the grid view. Okay, utilities plan, day operators, okay. Officers, admin, okay, that's correct. It's 420, okay. Sorry, I thought I see the wrong thing. Okay, 35 people at night. And fraction of population indoors is 1. Control room. Control room, why doesn't control room have the population?
Mine isn't showing it either, but I entered it in the other view,
okay.
not in grid, but I try to enter it here and it just disappears.
Disappear, yeah, okay, it's the same here, okay. Let's skip control room for the time being, and we move to the last one, process area. So it's 100 people at night, and the fraction indoors is 0.9. And then just to be sure, we double click at control room in order to make sure that there is, so we change the 15 people to 8 people. The process, the population category is process control, and the fraction indoor is 1. So that's all right. Okay, so we have completed this population insert. Okay, so we have done this for the on-site. So the next thing is I'm going to show you the off-site population, and that involves a very complex geometry, because as you can see in the PowerPoint presentation slide here, we have 5 population that is off-site, located at the West Town. This is the residential population, and then we have a Stone Quarry. This is industrial population, and then we have East Town. This is also residential population. Then we have 2 adjacent facilities which doesn't belong to the plant in the middle here, namely a fuel storage depot and chemicals plant. Okay, so these 2 adjacent facilities are located close to this plant here, but the population are not workers of this plant. They are considered as industrial workers. Okay, so we are going to the off-site population, the relevant data, the number of population and the fraction indoors for both daytime and nighttime are being tabulated in this table. The category also show that, okay, the West Town and East Town population are public, the Stone Quarry population are other, the fuel storage depot and the chemical plant, the population is maintenance and process control respectively. So I switch my screen back to the software. So we'll carry on drawing out the offsite population. So I'll first define the easy geometry shapes. So I'll start with Stone Quarry. So right click at the population, insert and choose a population rectangle. So this is for the Stone Quarry. So we just do. Okay, you do not need to draw very accurately. So I've just, okay. So this is a Stone Quarry. Rename it to Stone Quarry. Then the next one is the fuel storage depot. It's also a population rectangle. And then rename it to fuel storage depot. The next one is chemicals plant. It's a population polygon. It's a rectangle, but here is a square. And then rename it to chemicals plant. Okay. Then I will do the difficult one. That is the West Town and the East Town. So I right click at the population folder and then click on insert. So I will choose population polygon. Okay, I'll always start at the top left corner. I'll recommend you to start at the top left corner. And in order to draw it fast, you can just keep clicking. Oops. Let me do it again. I'll try to draw a nicer one. So at the end, you can actually just right click, and then there's a selection. There's a list of 3 selections for you. And then just click on finish. So to draw it fast is to click at many points. So now rename the population polygon to West Town. And next I will do for East Town. Always start with the top left corner. Okay, so the top left corner is at this location. Yeah. And to draw it fast is to keep clicking along the way as your mouse moves. So I renamed this to East Town. So we are going to insert the population and the fraction. Then we are going to do a copy and paste and then insert the nighttime data. So I double click at the stone quarry. The population for the stone quarry is 250 during daytime, and the category is other. And the fraction of indoor is 0.3. Then click on OK. The next one is the fuel storage depot. The category is maintenance, and the population is 40. And the fraction of population indoor is 0.8. Click on OK. Double click at the chemical spawn. Oh, yeah, okay. Let's stop here for the time being, okay? Because I've done for the first two. So the next few and for nighttime we are going to use the grid method to insert. So let's do a duplicate. That means copy and paste the stone quarry, the fuel storage depot, the chemicals plant, the west town, and the east town. So let's copy and paste. Okay, then the next thing is click on populations. And make sure that your mouse highlight is at the populations level. Then click on grid.
Richard, your grid view is locked. You have to unlock it.
It's locked.
Yeah.
Lock. Yeah. Okay. Yeah, unlock. If this is locked, please unlock it. So I can change the stone quarry name at the grid view. So I'll do it here. Okay, now I'm at chemicals plant. So first rename it to chemicals plant day. And then the category, I'll choose process control. The population is 200. And the fraction is 0.5. Then the west town. First rename it to west town underscore day. Then the category is public. The population is 10,000. and the fraction indoor is 0.6. Okay, then we rename the East Town to East Town _ day. The category is also public. The population is 12,000.
And we got a question.
And
here.
the fraction is 0.6.
We got a question here. Does population category have any impacts on risk calculations?
The risk calculations, if you are referring to location-specific individual risk contours, then there is no impact. If you are referring to societal risks, then there is the total risk will still be the same, but the different categories of the population, it allows the software to break down the PLL and the societal risk for you, and to report them according to each category.
Yes. So basically, the population category doesn't affect the total risk PLL or your FN curve. But if you want to see different risk for different population category, you can define the population category here. Then when we generate the PLL results later, you will be able to see the PLL for each category.
Now, for a very simple reason why we need to separate the population into different categories, because maintenance will definitely have a different risk level than admin workers. Admin workers, they are staying indoors most of the time. So their risk level is definitely different from maintenance workers. And if let's say the admin workers, they come to work on a 9 to 5 basis, and then they work 5 days a week. And for the maintenance workers, they have to come to the plant and they have to work on a 12-hour shift. Okay, 12-hour shift and 7 days a week, but probably they get the next week off. So different working pattern that would cause the maintenance workers to have a different risk level than admin workers. So this is the motivation behind why we put the population into different categories. All right, so now let's carry on. Let me complete this. Okay, so now I renamed the stone quarry to night, stone quarry _ night, and yeah, okay, the population is other. Then the nighttime population is 15, and the fraction is 1. And the fuel storage depot, rename it to fuel storage depot _ night. The category is maintenance. The population is 5. And the fraction of indoor is 1. And the chemicals plant, it's a chemicals plant _ night. The population category is process control. The number of people is 10 people, 10 person. Fraction indoor is 1. Okay, then now we rename West Town to West Town Night. Category is public. Number of people is 21,000. Fraction indoor 0.9. East Town. Number of people is 26,000, and fraction indoor is 0.9.
Hi, Richard. Can I ask a question?
Yeah, sure. Please go ahead and shoot.
Someone who is building the study up, are these the fraction of population? Is there a data source where we can get standard values, or is this? How do we decide on the fraction of population?
These are all based on assumptions. So you have to sort of like ask the workers around, okay, and you get an estimate of how many hours do they spend outdoor. Like for example, maintenance workers, if they have a 15 minutes break time, likely that they will spend the break time indoors. If most of the time they are outside doing field work, then you may want to put a 90% of fraction outdoor.
Okay. Okay.
Yeah. So this is just a very rough estimation, and because you can't really stop a person from going outdoor or staying indoor. So these are just rough estimates. Yeah.
Okay.
Okay. I hope you have finished the data input for population. Okay. So because of the complex geometry, so it's going to take a lot of time. But the key point to drawing fast is to keep clicking along the way when your mouse moves. You keep clicking, okay. And there's some accuracy issues because it depends on how you draw the geometry. The numbers calculated will be slightly different. But yeah, this this calculation is not it's not rocket science that you are required to be extremely accurate. Yeah, a lot of the data is actually estimates, including the event frequencies, the leak frequencies that you key in, they are just estimates. Okay. So up to this point, I would like to move on to the next part, and that is the ignition. Okay. First of all, I would talk about where does the ignition data come from. So in this slide, you see that it comes from there are three document covers. One is the IOGP, and then the other one is the CCPS, and you have the RIVM BEVI. So you can make reference to these different references. Okay, these provide you with comprehensive data for you to key into the software. So what are the ignition data that the software will require? Okay, but a very basic information is that ignition is divided into immediate ignition and delay ignition. This is something that you have to bear in mind. Okay, immediate ignition and delay ignition. Okay, and then there are different options of immediate ignition. You can either use event trees. Use event trees meaning that you are using the event trees that are inbuilt inside the software. Later, I will show you what are the event trees being used by the software. And then the next thing is specify directly. Specify directly is user they themselves provide the number. That means you key in the number yourself. That is specify directly. Okay, and stationary use material reactivity. This is from Purple Book. If you decide to use this, okay, then you will not be able to see the calculation process, but the source of data is from the Purple Book. Okay, and then transport road tanker or tank wagon. This is also from Purple Book. Okay. Then use Cox, Lees, and Ang, or UKOOA, or we would like to say that it's UKOA. Okay. Cox, Lees, and Ang is being abbreviated as CLA. And then UKOA is a United Kingdom Offshore Oil. United Kingdom Oil Operators Association. Yeah. So you have these few options. Okay. And then now I will switch the screen to the software so that I can show you the event trees. Okay. Okay. So for to call out the event trees, if you will go to help, the help tab at the top, okay, and then click on show help. Okay. Click on show help and then expand the window. Then you click on search, all right, and then type event tree. and click on list topics. Okay, then you would see that there is an event tree parameters. All right, you will see that there is event tree parameters. Click on it. Okay, so now double click on event tree parameters. Then you will be able to see the tree for continuous release without rainout, see the tree for continuous release with rainout, see it tree for instantaneous release without rainout, and see tree for instantaneous release with rainout. So if you click on this icon that is next to see tree for continuous release without rainout, then it will show the event tree. All right. So if you go back and click on the next one, then you will see the different event tree. Then you click on the third one, you see the third event tree and the last event tree. So this is where you can get the event tree of the software.
Richard, this event trees doesn't have the probabilities values included.
Yeah, the values there are values for each of the tree branch. Okay, and the values can be found in, if you go to parameters tab. Okay, at this software, go to parameters tab, and under the parameters set, double click at event tree parameters. Okay, then you find that except for standalones and explosion probabilities, then the rest, okay, the continuous no rainout, continuous rainout, instantaneous no rainout, instantaneous rainout, okay, these are the numbers for the branch, for each of the 3 branches at the event tree there. Okay.
Okay.
Yeah. Okay, so just to keep your heads up, the next exercise is coming up because we are going to put in the ignition sources on the map. Yeah. So I will switch my screen to the PowerPoint now. So I've explained for immediate ignition probabilities, you have different options. Okay, the specify directly option allows you to key in the number directly. Yeah, if you have an alternative source that is not from CLA, UKOA, or the Purple Book, if your numbers are coming from CCPS, you can use specify directly. Okay, then delay ignition. So delay ignition, there are 3 options. One is to calculate minimum probability of delay ignition. So if you are using this option, calculate, that means the keyword is calculate, then the software will actually take into consideration the ignition sources that you define on the map. So if you have defined nothing, on the map, then your delay ignition probability will be 0. Okay. Now, if you use minimum probability of delay ignition, this is another meaning of user specify. Yeah. If the keyword is if the word here is used, that means you as the user will supply the delay ignition probability yourself into the software. Okay, and then third one is UCLA or UKOA. Okay, this is using the Cox, Lees, and Ang or the UKOA ignition probabilities. Okay, so if you choose this option, at the below the software, you will be able to choose the different types of ignition probabilities. Because the UKOA ignition model is based on the different facilities type. You can see in the list here, you have the pipe, you have the small plant or a large plant, whether it's a liquid or a gas. Okay, so the delay ignition sources are entered at the risk tab. Again, it's a risk tab. So just now when we enter the population is at the risk tab. So now when we enter the ignition folder is just above population. So same thing, you would just right click at the ignition and then choose insert. And then there are different shapes. You have ignition point, polygon, rectangle. Okay, then you have something different, slightly different here, that is electrical line or electrical polyline. So if you think that the electrical line can also be an ignition source, which is normally not the case because electrical lines are insulated with polymer, so it has a layer of insulation. So it's not really likely that electrical line can be ignition sources. But just in the event that you will need to define electrical line as ignition sources, the option is provided here. Okay, so electrical line, this is a straight line. Polyline is you can bend it. Okay, and then for transportation line is used to refer to vehicles that is running around the plant, vehicles that is running inside the plant or outside the plant. So you have roads leading up to the plant. So you have vehicles traveling on the roads. And these vehicles outside of the plant would not have a flame arrestor, would not have the spark arrestor. So it's likely that there will be ignition source. So you will need to define the number of vehicles outside of the plant, and then at what speed are they traveling. Okay, let's take a look at the ignitions, the data requirement for the ignition sources. Up to this part, we are talking about delay ignition. So immediate ignition is already over. We are talking about delay ignition. So for general and electrical ignition sources, that means ignition point, ignition polygon, ignition rectangle, electrical line, and electrical polyline. The three data required is ignition probability, in time period, and operating probability. Okay, so where do we get all this data from? Now, this data can be taken from Purple Book. Okay, so all this data can be taken from Purple Book. Ignition probability, in time period, operating probability. Later, I will explain what does each of these data mean. Then for transportation, we will need to provide the ignition probability. In time period, again, these two are coming from Purple Book. And then you need to provide the traffic density. How many vehicles pass by in an hour's time? How many vehicles per hour? And the average speed. Now be careful with the average speed because the average speed is in meter per second, whereas the vehicle speed is always kilometer per hour. So just take note of the unit difference. Okay. So now the ignition sources, the ignition probability, in time period, and operating probability. Now the presence factor is referring to operating probability, which means that is your equipment operating 24 hours a day? Or if your equipment is only operating 5 hours a day, so the presence factor here, it will be 5/24. Okay, this is because the presence factor is a number that we key in to account for the possibility that when there is a gas release, it's possible that your equipment is not operating, it's shut down. So that shutdown equipment may not be the ignition source. So there's such probability. So the presence factor is referring to the operating probability. Okay, And then for the initial probability and in time period, for these two parameters, you refer to the formula down here. Okay, the numbers are given in purple book. It's basically based on the calculation of this formula. Let's say for a typical ignition source, that you have a graph of ignition probability versus time, and time is referring to the time when the gas cloud is come into contact with the ignition source. So the gas cloud come into contact with the ignition source for 200 seconds. When the gas cloud has come into contact with the ignition source for 50 seconds, the ignition probability has increased from 0 to 0.7. So you can input 0.7 as the ignition probability and the time period as 50 seconds. Okay, and the software will calculate, or based on these two inputs, calculate the other parameters. Okay, and get this graph. Okay. So this ignition probability, you can put 0.7 in time period of 50 seconds, or you can also put 0.9 in time period of 100 seconds. So this is how you put in. Put in the numbers for these three parameters. So now we are coming to this exercise. So this is not an easy exercise because we can see that we have to map out the route which are acting as ignition sources for the site, because these are the roads that pass by the plant. Okay, for roads that didn't pass by the plants, I think we can just omit it. Okay, we have particularly chosen the roads that pass by the site. Okay, this includes the valley road, and then the industrial service road that is linking the port. Now what you see here is the sea. Okay, so this is actually the port. The industrial service road links the port to the site, and then you have a highway that passes by the site as well. Okay, and then for the site, we also define it as an overall ignition source. Okay, so in the case that there are so many ignition sources inside the site, we can just combine it as one overall ignition source, one big ignition source. Okay, we can just
This is like one small doubt. This road length, how we can decide? Because for an example, the road leading to the port, you are showing up to the point of port. Is it required to put the ignition sources from the site up to the port, or we can stop at boundary of the site? Likewise, for the valley road, you have started from the top left to the bottom right. Is it the entire road need to be considered as ignition source, or we can limit the road which is near to the site?
Yeah, I tend to agree with you. I think you can stop at the boundary, meaning that that means you can cut off at the boundary. Because if you think that the gas cloud will not travel out of the site to very far away places, then I think it's okay to cut off at the boundary.
Thank you.
Yeah. Now, I do agree with you that this highway is very far. So I think because we to account for the possibility that the gas cloud will actually travel out of the site, but normally I think we can just cut off here. This is simply too far away. We can dismiss it. Yeah, but for the purpose of this exercise, let's just draw the valley road, the highway, and the industrial service road from the beginning to the end. Okay, yeah, just for the sake of completeness. Okay, yeah, so just now I was talking about, yeah, you can combine all the ignition sources in one location as one overall big emissions area. Okay, let's say for example this tank farm here, if there are simply too many emission sources and we are not going to define point by point. Okay, let's say if every single tank at this port here is an emission source, if you have to define it point by point, that is going to take a lot of time. So a simple way would be just to draw an area over it, and then the whole area will be defined as an emission source. So this is how we deal with the emission source, the residential emission source. Yeah, this is to convenient the users in order to, if there are simply too many emission sources, so we can just lump it. Lump it under one area, under one combined emission source. Okay, so now the next slide, this provides with the details, the data details of the emission sources. We have the emission probability given in time period, and then you have the daytime and nighttime. So after drawing, we will have to copy and paste to duplicate for nighttime as well. Okay, so with reference to this table here, I'm going to switch over to the software, and we're going to do exercise on how to insert the delay emission sources on the map. Okay, so let's click at the risk tab, and then look for the emission folder. Okay, and then click on GIS input. Okay, now I do not want the population, all these population shaded areas to interfere with my judgment. So I'm going to switch off all these population areas on the map. So I can do this by going to the legend and look for populations. Right click at the populations and then choose display off. So that will switch off all the population, and I can now have a clean map to work on. So let's click on emissions and then click on insert. Okay, let's choose a transportation polyline, and we will start with Valley Road. Okay, just give me 1 minute. Okay, the Valley Road starts from here, this corner. So again, the key to draw fast is to keep clicking on along the way as your mouse moves. So rename this transportation polyline to Valley Road. And then the next thing is right click at the emission folder and then click on insert transportation polyline. We are now going to do for highway. So highway starts from this point.
Richard, 5 minutes to lunch break.
Okay. Okay, rename it to highway. And then the next one, industrial service road. It's transportation polyline again. And then we start from here. And then leading the way to the port. So the last one is we will draw an initial area for the plant itself. So right click on it. Oh, sorry. Before that, let's rename the transportation polyline to Industrial Service Road. So let's right click on the ignitions again. And then this time around, we are going to choose ignition polygon. And then draw along the boundary of the plant. Okay. Then rename it to site. Okay, now we are going to copy and paste. Then we are going to, after copy and paste, we are going to use the grid view to insert the data.
Richard, we got 2 questions here. Question 1.
Okay.
If I choose CLA or Yukawa ignition model, do I still need to define the locations of ignition source?
Answer is no need because CLA, UKOA, it's statistical instead of based on what you define on the map. So you if you choose CLA or UKOA for delay ignition sources, then you do not need to define the ignition sources on the map.
Yep. Next question. For ignition, in this case, if the ignition source is not hit, does it mean no ignition?
Yes. If the ignition is not hit, then there is no ignition.
Yeah. Actually, for everybody, if you go to the slides 42 of our handouts, there is a link. There is a link to the webinar, which is our ignition source modeling webinar, which was held last month. So we have our consultant there talking about ignition. So if you want to know more about ignition, you can refer to that webinar. Yeah, here. If you go to the link, there is a link. It links to a webinar. So it's a 1-hour webinar. You can watch the video to know more about ignitions. Yeah, in this training, because we only have 1 day to cover Safeti, so we couldn't cover everything in details.
Yeah, regarding this delay ignition sources, between the use of CLA, UKOA, and actual ignition sources on site, that means you define the ignition sources on the map, that generates quite a lot of discussion among the users. We often get these kind of questions about whether to use CLA, UKOA, or whether is it better to actually define the ignition sources on the map. So this this webinar is a good discussion. I hope you can get some useful information from this webinar. Yeah, I would personally like to explain about this issue, but also it will take about 2 to 3 hours just to explain it alone, because that involves a lot of demonstration of how it works for the UKOA and also how it works for the actual ignition sources on the map. Yeah. Okay, so now it's 12 o'clock. So let's break for lunch, and we will come back at 1 o'clock to continue. Yeah. So I stop here. That means after lunch, I would continue to copy and paste the ignition sources. Then after that, I will key in the data for the ignition sources using grid view. Okay, before moving on to the next part, the next topic. Okay, thank you, everyone. Thank you very much.
Yeah, thanks, Richard. So thanks, everybody. See you in 1 hour.
All these initial sources. So first I start with value road. I name it to value road daytime. And the ignition probability is 0.2 in time period of 10 seconds. The traffic density for daytime is 800 cars per hour and traveling at an average speed of 20 meters per second. So I put in 820 meters per second. So then the next row is the highway. I rename it to highway day underscore day. The initial probability is also 0.2 in time period of 10 seconds, same as the valley road. So the traffic density is 3,000 cars per hour and traveling at an average speed of 30 meters per second. So the next one is industrial service road. Then industrial service road underscore day. That is how I would rename it. Ignition probability is 0.2 in a time period of 10 seconds. The traffic density is 10 vehicles per hour and average speed is 15 meters per second. Now I've come to a repeat valley road. So I will rename it to valley road underscore night. Retaining the initial probability, retaining the in time period. The traffic density is 100 cars per hour with average speed of 20 meters per second. And the next row is highway. We name it to underscore night. And the traffic density is 1,000 cars per hour, traveling at the same speed, 30 meters per second. Okay, and now we are at the row of industrial service road. So during nighttime, the traffic density is 2 cars per hour. And the speed is 10 meters per second. So with that, we have completed the data input for the transportation ignition sources. So next we choose ignition source. Yeah. Okay, in the drop-down list, choose ignition source. Okay. So we name the site into site underscore day and site underscore night. The ignition probability for both day and night is 0.9 in time period of 10 seconds. The operating probability is 1 during daytime and 0.9 during nighttime. Okay, so with that, we completed the data input for all the ignition sources. Okay, so we have completed 2 very rigorous exercises of inputting the ignition sources as well as the population data into the map. So now we are moving on to the next part, that is the risk ranking point. So what is the purpose of inserting the risk ranking point, and what are risk ranking points? So basically, risk ranking points are points that we insert on the map so that when we run the model, the risk ranking points, depending on its location, will help us to extract the location-specific individual risks at the location that the risk ranking point is located. Now we understand from the risk ranking point, we understand from the LSIR Let me go back to the slide where I'm showing the risk ranking, where I'm showing the LSIR. Okay, sorry, just hold on. Okay, so this is a picture of the risk ranking point, and from this picture, we are able to tell that at different location, the risk level is different. So if let's say I am in this location, and when I'm in this location, the risk level are different because one is within the contour of 1e minus 5, and another one is within the contour of 1e minus 6. So in this sense, if I'm located inside the contour of 1e minus 5, the risk level is higher than being outside of it. So risk ranking points will help us to extract the risk level at different locations and also tell us which scenarios contributed to the risk at that location. Okay, so we are going to insert, okay, you can insert as many risk ranking points as you want. Okay, any number of points can be used. Now the risk ranking points will generate the risk ranking results, okay, which first show the risk ranking point, and then it will show what kind of vulnerability standard, whether it's outdoor vulnerability or indoor vulnerability. So, and then it will show us the scenario that is contributing to the risk at the control room. So in this example, we are using the example of putting a risk ranking point at the control room. And the risk ranking point tells us that ammonia rupture is the main contribution of the risk at the control room using outdoor vulnerability standards. So we are going to do an exercise by just defining 4 risk ranking points at the following location. Now, one is the control room, and the other one is the chemical plant, West Town and East Town. Now, we know that apart from control room, chemical plant and West Town and East Town extends over a large area. So where should we put the risk ranking point for chemical plant, for West Town and East Town? So usually I will choose location that is nearest to the site. Okay, the nearest spot, the nearest point of the chemical plant, or the nearest spot or the nearest point of the West Town and East Town to the site. Okay, because this will enable me to understand if the risk is coming from my plant, what are the scenarios that will contribute to the risk to the residents of West Town, or to the residents of East Town, or to the workers at chemical plant. Okay, so let's switch the screen to the software. Okay, and let's remain in the risk tab. And then if we scroll down to the bottom, then we will be able to see a risk ranking points folder. So right click and then insert and choose risk ranking point. And all that you have to do is to insert the point on the map. So first of all, we will insert at the control room. So the control room is located as this location. Okay, if the shaded area is interfering with your judgment, if you are not able to see very clearly where is the control room, what I would suggest is to switch off all the ignition sources so that we can have a clear map. So we do this by going to legend that is on the left-hand side of the map. Then we right-click at ignitions, and then choose display off. So this will clear off the map for us. Okay, so then the control room is located at this location. So I will insert a risk ranking point at this location. And then you will see a risk ranking point that is being inserted under this folder. And now we should rename this risk ranking point to control room. Okay. And next, we are going to insert a risk ranking point at the chemical plant. And we know that for the chemical plant, this face is facing the site. It's closest to the plant. So I will choose a risk ranking point at the chemical plant boundary that is nearest to the site, so that I can capture what are the scenarios that has potential to get out of the boundary of the plant and extend into the chemical plant. So here I would right-click at the risk ranking points folder, insert risk ranking point, and put it somewhere in the middle of the face of the chemical plant that is facing the site. So I'll put here, and I'll name this risk ranking point as chemical plant. Okay. Then next, we'll put two more risk ranking points, one at West Town and one at East Town respectively. For the West Town, this is the point that is closest to the site. So by putting a risk ranking point here, I will be able to capture which are the scenarios from the site that has potential to reach over or to spill over to the West Town. So I insert a risk ranking point at the edge of the West Town, and I name this risk ranking point as West Town. Then the last risk ranking point to be inserted is the East Town. So I'm going to right click at the risk ranking points folder, choose insert, click on risk ranking point, and I'll choose a spot that is nearest to the site. So I choose this location. I'm sorry, actually this is already out of the the East Town. So I'm going to delete it, and I'm going to reinsert the risk ranking point again. So I'll choose this part because this is the closest location to the site. So it will help me to capture what scenarios has the potential to reach over to the East Town. Yeah. So by inserting the risk ranking points, we would have completed the exercise. Okay, and now it's time for us to open a new model, a model that has a model that is a standard issue for everybody, because later when we do the quiz, I want everybody to get the same results. So let's go and open the exercise study file. Okay, yeah. Can you please open number 5, Safeti Training, RRPs. RRP stand for Risk Ranking Point, .psux. So number 5, so open the file. Okay, once you have opened it, now let's move to the presentation slide. Okay, the next slide is showing the event tree data. So this one I've shown earlier on. If you click at the parameters tab, and then double click at the event tree parameters, you'll be able to get the numbers for the 3 branches of the event tree that is being used in the software. And then the next thing is I would like to introduce you to vulnerabilities. There are 2 vulnerabilities. One is the outdoor vulnerability, and the other one is the indoor vulnerability. Now, imagine a person, he spends certain time outdoor and he spends certain time indoor. Indoor, we refer to being inside a building, and this building could be made of concrete or made of bricks, so it's stable enough to withstand certain fire and also certain explosion. Okay, so in that case, a person that is being inside a building is less likely to be killed than a person that is located outside of the building, because the building will provide certain form of protection for the people inside the building from explosion, from fire, and even from toxic. So indoor vulnerability would have a different vulnerability numbers than the outdoor vulnerability. In general, it is the common sense that indoor vulnerability would have higher survivability, or it requires a higher explosion or a fire radiation in order to kill somebody inside a building. Okay. So after introducing you to outdoor and indoor vulnerability, now we come to the risk criteria. So it's time for us to set up the risk criteria so that we can generate the results according to the risk level that we set here. In this case, we are going to set the risk level that we are going to generate, which we are going to generate the contours. So we are going to generate the contours for 1e minus 2 up to 1e minus 8. So how do we do that? That is, let's go to the settings tab at the top and then click on risk preferences. So I'm going to switch my screen to the software. Okay. And now I have opened up the new model, which has the last exercise being completed. That is a risk ranking point. If I go to risk tab, yeah, I will see that the risk ranking points have been inserted for me. Okay, so we go to the top, click on the settings tab, and then click on risk preferences. The next thing is we click on contours. Okay, and we are going to insert 1e minus 2, 1e minus 3, all the way to 1e minus 8 in this table. So if you like to make it larger, then you can click on this button, click on this icon over here to drag it larger. So I'm going to put in 1e minus 2, followed by 1e minus 3. Okay, just something to note that actually you will need to double click on the next row. Yeah, in order for you to be able to insert something. Okay, so what you have to do is insert from 1e minus 2 all the way until 1e minus 8 and stop there. Okay, click on OK and close the window. Okay, next, we are going to set up the FN curve. And for this FN curve, we are going to follow the UK standard. So in the previous slide, I've shown you the different standards, okay? And each standard has a different FN curve criteria. So for this, we are going to follow UK, and this is what we are going to put in. We're going to put in 1e minus 5, then the fatality 1, 1e minus 7, fatality 10, 1E minus 3, fatality 1, 1E minus 5, fatality 10. This is to set up the minimum and maximum risk line, the starting point and the ending point. And as we go back to the software, okay, there's one question which I'm going to read out. If I require the risk ranking of site boundary, what steps do you recommend us to get the ranking? Well, you can just insert the risk ranking at the site boundary. And if 1 point is not sufficient, then you can insert 2, 3 points. And there's no limit to how many risk ranking points you can insert. You can just insert as many risk ranking points as possible. Okay, now we are at the software and we are going to set up the FN curve criteria. So same thing, let's go to the settings tab and click on the risk preferences. Then click on charts, the charts tab. So I'm going to expand this, easier for me to put in the lines. Okay, so here we have a number of criterion lines. Okay, the number of criterion lines is 2. And you have the minimum criterion line and the maximum criterion line. Okay, so first we start with minimum criterion line. The minimum criterion line, the starting frequency is 1E minus 5, and the end frequency is 1E minus 7. So there's nothing for us to change here. The minimum number of fatalities is 1, and the maximum number of fatalities is 10. Also, there's nothing for us to change here. And let's take a look at maximum criterion line. The starting frequency is 1E minus 3, and the ending frequency is 1E minus 5. The minimum number of fatalities is 1, and the maximum number of fatalities is 10. So we just have to key in 1 and 10. And click OK. So we have set, okay, the risk level that we want for the risk contours, and we have also set the FN curve criteria. So now let's take a look at the study structure, the next part of the presentation slide. So I'm going to switch my screen over to the PowerPoint. Okay, so here this is the study structure. Okay, capturing inputs, just some useful information. The QRA is not an isolated study performed by a risk analyst, because the risk analyst will need inputs from the structural engineers, from the schedulers, such as the admin workers, how many days they spend working in the plant, what is the rotation shift for the maintenance workers. Facilities engineers, okay, facilities engineers that are in charge of different process units. Workforce, the pipeline engineers that can give you valuable input of how many pipelines are there in the plant. The pipelines are, an average, are they how many? What is the diameter? What is the average diameter of the pipelines in the plant? Perhaps they can give you some useful inputs in this. And then transport supervisors, do they have any data of the traffic outside of the plant? Yeah. And operators, basically, how do they operate the plant? So it's a collective effort to get input from everyone. Because a risk analyst, he is only focusing on doing the QRA, but he would need input from everybody. So the QRA is also not a one person's job. It's always a collective effort. Yeah, it's imperative to get everybody's involvement to make the QRA study a success. Now, to organize the study, the scope and objective of the study is very important. It depends on the location where you have the study. Do you need to generate the results according to what standard are you using? Are you using Singapore standard? Are you using Australian standard? Or are you using UK standard? So which standard are you following? Because that would affect the strategy you have for the QRA study. Just like how I set up the risk level for the risk contours, and also how I set up the FN curve. Using different standard, I will have different requirements or different starting frequency, ending frequency, minimum fatalities, maximum fatalities for the FN curve. Okay, so we need to be as clear as possible. What is the scope and what is the objective of the study? Does my study need to involve the population around the plant? If I do not need to involve the population around the plant, that is probably easier for me because I do not have to collect the population data of the residential areas around the plant. Okay, if I just would like to understand the risk, okay, within my plant, I do not have to care about the impact to my neighbors. So then I do not have to collect data from my neighbors, whether it's an industrial facility or whether it's a residential facility. Okay, the study needs to be designed to reflect its purpose. What are we considering? Are we considering different weather conditions? In this case, we are considering day and night. Are we considering the population? Is there a difference between the daytime population and the nighttime population? And then are we considering different process options? Like, for example, I shut down plant A, then I'm operating plant B, or I shut down plant B to operate plant A, or when I shut down both, or when I operate both plants, what would be the risk level? Okay, then do I need to consider different location for release? Do I need to consider to move my on-site buildings around? Okay, and then the different emission sources. Yeah, is there a difference between daytime emission sources and nighttime emission sources? For example, we know that the traffic, there are more cars during the daytime, so that present higher emission risk for the plant. And during nighttime, there are less traffic, so there's lower risk emission risk for the plant. So this is, again, repeating what we have presented earlier on. The inputs required by Safeti are release cases. You must first have the scenarios and their frequencies. In this case, this is referring to the leak frequencies. Then we need to have the weather condition. You will need to have the wind speed and wind direction probability, the frequency that they blow from one direction, from all directions. And at what frequency are they blowing at this wind speed? You will need to have the maps, the population data, the emission sources, and also the risk ranking points is what you would require in order for you to understand the risk level at different locations.
Richard, there was a question in the morning. Any open source available to collect windrows for the allocation of our interests? Basically, Alan is asking for wind weather data.
Yeah, he can try Google, because I think there are a few websites that provide windrows data. I think windrows data is available for major airports in the world. Okay, because airports they have weather stations, so they will collect weather data that is open source. That is, I've forgotten the website address, but I think you can, he can try Google. Okay, then, okay, but for very specific project locations, this is usually the weather data is usually somehow is classified information. So it's possible to get the weather data from design basis documents.
Yeah. So basically, to add Richard's answer, actually, if you do a standard query according to a local regulation or local query guidance, it is quite common that the weather data is already included in such guidance. But if not, you can follow Richard's advice. You may refer to local weather. Basically, the weather is is available somehow in the local meteorologic regulators authorities. Maybe Richard, we can prepare a formal answer for this after this training.
Thank you.
Okay, for the case of China, most of the time they need to buy from the weather station. Yeah. So I don't know about other countries such as Korea. I'm not sure. But I know for Singapore it's already in the guidance document. For Malaysia, you will need to also buy from a weather station. So the cost of buying the data from the weather station has to be included in your quotation for your customer. So yeah. Okay, let's carry on. Okay, so we have now we have a situation whereby we have a different population during daytime and nighttime, and then sorry, we have different ignition sources during daytime and nighttime. We also have different weather conditions during daytime and nighttime. And for certain countries, it's more extreme because you have different weather conditions for different seasons. During winter and during summer, it's different average temperature. So all this will need to be taken into account. And how do we set the condition? How do we set the weather condition? How do we set the population? How do we set the ignition to run a model? So we do this by defining the run rows. The run rows is basically a row where you specify the conditions to run the model. Okay, so here we can have a table. First, we define the run row name. We can call it a flammable or toxic, or flammable day, flammable night, or toxic day, toxic night. Then what are the release cases that we are going to run for this run row? So let's say if I name this run row as 1 and 2, very simple name, 1 and 2. So what are the release cases that I run for 1 and 2? So is it all the release cases? I can choose all the release cases for both run rows. And then for the weather conditions, I can choose day for run row number 1 and night for run row number 2. So same for population, I can choose for day population and night population, day ignition and night ignition. So this is how I set up 2 run rows. So I set the daytime conditions and the nighttime conditions to run the model. Okay, and for another example, if we want to perform a study to analyze the risk posed by 2 different plant layout options, so we can set 1 run row to run the first option and the second run row to run the second option. Then we can set this run row to run the cases of location 1, and we can set this run row to run cases of location 2. And these 2 run rows will run the same weather condition, population, and ignition. Okay, and let's say if we want to separate the results, we want to know the toxic results and the flammable results separately. We can do this by run row as well. Okay, so in this run row, again, run row 1 and run row 2, my release cases would be 1 for flammable and the second one for toxic. And I could be running the same weather conditions, the same population, and the same ignition. So the results generated would give me flammable results and toxic results being separated. Then I will be able to compare between these 2 results, which has a higher level of risk and which has a larger contour.
Sorry, just on that one. The ignition sources for the toxic case, would you just have that as empty, like no ignition sources, if you were only wanting to look at the toxic effects?
Yes, it's possible. You can set toxic for toxic cases. You do not have to define the ignition sources, but that's unless your material is toxic only. Certain materials are both flammable and toxic. So if these materials they are not burned off, then if these materials are not burned off, then the toxicity will not be neutralized, and so once they release, they will give out the toxic risk. But if these materials, because they have the flammable features, meaning that they can be ignited and burned off, so their toxic risk will be lower if they are being ignited.
Okay. Yeah.
Thank you. All right. Okay, let's move on to example number 4. Okay. So what if we have more things to consider? Now, not only we need to consider day and night, we need to consider toxic and flammable. We also need to consider on-site and off-site population, and we need to consider summer and winter. So with such a combination, we can have up to okay, this is not the limit of the number of run rows that we can have, but this shows you that a corollary study can get this complex when we split into 16 run rows, and each run row has a different condition. So in general, you can see that it's split into toxic and flammable. That's the first column. But the next column you are able to see is we have summer and winter, day and night. So it's mixed together now. Then we have a population on-site day and population on-site night, and then we have population off-site day and we have population off-site night. So it becomes complex and becomes difficult to it's become rather challenging to handle. Yeah, but this is when run rows can help you to organize, and at the end of the simulation, the software will also give you one combined results, or you can also split the results according to run row individually. So this is the beauty of run rows, because you can set as many run rows as possible, and then you can choose for the software to combine the results together, or you can choose for the software to generate the results according to each individual run rows. Oops. Okay. So after this example study design 4, okay, please pay attention now, because the first question is coming. Okay. After explaining, I hope that you will be able to answer this question. That is question number 1. Okay. How many run rows should we define if we distinguish the risk for day and night? Okay. There is one word missing here, is day and night. Okay. Toxic and flammable. Okay. So Aiden, please launch the poll. Okay. The first question is, the first answer, A is 2, B 4, C 8. So please give your answer. Okay. Has everybody finished answering? Okay. Yeah, somebody raise your hand. Yeah, any question?
Just, click on the thing, or you have to type in the answer?
In the control panel for GoToWebinar, click on polls. Can you see the polls?
No.
Joseph, we have already closed the poll for this question. Maybe you can try that out on the next question.
Okay.
All right.
Okay, so I will review the answer. The answer is the 4. Yeah. How is it so? Because we say that we would like to distinguish the risks for day and night. Okay, and then toxic and flammable. So if you have one run row for toxic, then you will need to split the toxic run row into day and night. Then if we have one run row for flammable, we need to split the run row for flammable into day and night. So that makes altogether 4 run rows. Okay. Okay, so we are coming into this exercise to define the run rows. Yeah, we will exercise on the software on splitting the run rows into 4 run rows and defining the conditions that we are going to run each run row. So I will switch the screen to the software. So, okay, first of all that we have to do is open the model. Then here at the very left-hand side, you have a run rows, study run row. Okay, and then click on this arrow. Okay. So first you must be aware of this run row that is being hidden here because it's not easy to spot this run row here. Then the next thing is click on the run row grid, right? Okay, click on the run row grid and then, okay, for the first run row, I'm going to change the name of the run row first. I name it as flammable day. Okay, and as I move on, the second column we have is models, third column weather folder, then fourth column weathers, then fifth column parameters, then sixth column populations, seventh column ignitions, eighth column obstructions, ninth column boundary, and 10 column offset. So altogether we have 10 columns. Okay. So after defining the first run row, so we just change the name for the first run row. Okay, and then can we look at the icons above? We have add, we have the active run row cannot be deleted. We have the delete function. Then we have the duplicate function. Okay, so I would like you to click on duplicate. So if you click on duplicate, it will duplicate the first run row. And this is where we want to change the name to flammable_night. Okay. And then we can also add 2 more run rows. Okay. So altogether we have 4 run rows. Then I will define the third run row to be toxic day. And the last run row to be toxic night. Okay. Okay. Now the next thing is, now we are going to decide which are the models for flammable, which are the models for toxic. So for flammable run rows, it will only run flammable models. For toxic run rows, it will only run toxic models. Okay, and in our model, we already have all these folders, which show you HCU, HPU, SRU, ISOM, CCR, NHT, ammonia storage, utility, tank farm, and chlorine storage. Okay, so how do we separate the models? from flammable and toxic, to distinguish the models between flammable and toxic. Now, let's double click at the box that is below the models column. Okay, you can click once. Sorry, you don't have to double click, and then click on the magnifying glass. Okay. After clicking on the magnifying glass, you will see that there is such a selection window. Okay, so it's gray at the moment. So let's click on this green color plus sign. It functions as creating a new playlist. Okay, we are going to name this playlist as flammable. So for this playlist, it will have all the flammable models. And we are going to choose all the flammable models. All right. So what we have to do is first we click on study. Okay, we choose everything. Okay, and then move them to the right-hand side first. Okay. Now we are going to remove those which are the toxic ones. Okay, which are the toxic ones? There are 3 toxic folders. The toxic folders are first the ammonia storage, second the chlorine storage, then the third one is the SRU. The SRU. Okay, so you check the box for SRU. Okay, if you check the box at the folder level, it will automatically check the boxes for the equipment and the scenarios level. And then check the box for ammonia and check the box for chlorine. Then you move them to the left-hand side. So we have removed the toxic models from the flammable models. Okay, then we just click OK. And then your models, now for this flammable day run row, it will be updated as flammable. So the next one for the flammable night run row, it is still showing as all. So we have created the playlist for flammable. So we can just click on the drop-down list and choose flammable. Okay. Then as we move to the next run row, the third run row, the toxic day run row, and if we click at the run row, if we click at the drop-down list, we only have all and flammable. So we have not created the playlist for toxic models. So we are going to create it now. So let's click on the magnifying glass. Then same thing again. We click on this green plus sign in order to create a new playlist. And we are going to name this new playlist as toxic. And then we move the toxic models, which include ammonia storage, chlorine storage, and SRU, and we move them to the right-hand side. And then we click on OK. Okay, so here for the models, it has been updated to toxic. Okay, and then for the last run row, we want it to run the toxic model. So we just click on the drop-down list and select toxic. Okay, then we move on to the weather folder. So the weather here, by default, it's all day weathers because we only have one weather folder, but we have already created the night weather folder as well. So if we click on the flammable night run row and we click on the drop-down list, it has a selection of day weather and night weathers. So let's click on night weathers. Okay, and we do the same for toxic night run row. Okay, so we have now we have the flammable day to be running day weather. We have the flammable night to be running night weather. We have the toxic day to be running day weather. We have the toxic night to be running night weathers. Now, the next column, weathers, and it's all. Okay, it just means that it will choose all the weather categories under the day weather folder. So it is okay to keep the selection here as all. and we can just move on. Okay, then for parameters column, okay, parameters, at this point of time, we only have one parameter set. You can create more than one parameter set and then choose the run row to be running different parameter set. But for this exercise, we have only one parameter set. So we keep this as it is, and then we move on to the population. Okay, so now population, if we click on the drop-down list, there's nothing. It's either none or all, okay? So let's create a playlist for day population and another separate playlist for the night population. So let's click on the magnifying glass, okay? And then click on this green plus sign to create a new playlist. And then now we are going to name this playlist as day population. Okay, and we are going to select the day population and move them to the right-hand side. Okay, for now, we are not considering on-site or off-site, okay? So all the day population, regardless of whether they are on-site or off-site, we just move them to the right-hand side. So we just check the boxes for all the population categories that bear the name of day at the end there. Okay, once done, move them to the right-hand side. And then click OK. Okay. Then we see that the population selection for flammable day run row has been updated to day population. So for the flammable night run row, we need to create another playlist for night population. So we do this by clicking at the magnifying glass, click at the green plus sign, and we rename the playlist to night population. And check the boxes for all the population that bears the name night at the end. So move them to the right-hand side and click OK.
You can also just search for it in the top left of the screen where you define the playlists. Just search for night and.
Yeah, exactly. You can go to the text filter and type nights, then all of the night populations will be there.
Yep.
Yep.
That's a useful function. Yeah, so it depends. It shows you the importance of naming your items correctly at the very beginning. So once you have inserted something, please remember to always name it, name your scenario, name your population, name your initial sources. Yeah, name it correctly, and then you will have a easier time when you make selections.
Richard, actually, it's also maybe possible to create a folder under population. It's even easier.
Yes, it's possible to create a folder. It's possible to create a folder so that it can help you to organize.
Yeah, because this will be useful if you have a lot of data. You can organize them in different folders.
Okay, so I will just quickly show how to create a folder. So we do this by going to the List tab. Okay. And for the populations, right-click at the populations folder, and then you can insert, and you can insert a folder. So you can name the folder as day population. All right, and then move all this to day population. Oops.
You use the cut at the top of the page.
I'm just dragging it down basically.
You can select all of them at one time and cut and paste.
Oh, okay. Yep.
There we go.
Okay, and then we are going to create another night population folder. Cut and then paste. Okay, so we have everything. Okay, let's carry on with the run row functions. Then now we are at the toxic day run row. So at the drop down list, let's choose the toxic. Let's choose the day population, and then for toxic night run row, choose the night population. Okay,
Richard,
and then
Richard, just now you changed, you create a folder. It's better to check if the data is correct. Yeah.
Oh, okay.
So, yeah, make sure it is correct here. Because you change the folder after you define the playlist, so yeah.
Okay, yeah, we need to ensure that day population consists only of day population groups and night population only of night population groups. Then we move on to ignitions. Okay, we do the same. Let's click on the magnifying glass, and now we are going to create two playlists. One playlist for day ignition sources and another playlist for night ignition sources. Okay. So I'll name this ignition sources as day ignition. And click on OK. And then for the night run row, create another playlist. Name it as the night. So apply the text filter, night. And then move all of them to the new playlist and name the playlist as night ignition. And click on OK. Okay, then for the remaining two run rows, it will just be selecting from the drop-down list. Okay, so in that case, for obstruction, boundary, and offset, we do not have anything for now. Okay, so we can just stop here. Okay, so this is an exercise for you to define run rows. Okay, now it's time for us to move back to the presentation slides. Okay, so I've demonstrated to you how to create the playlist. This is first by clicking the magnifying glass icon, and then after that, click on this green plus sign icon. Then you'll be able to create playlists, and remember to name your playlist. And then when you make a selection, check the box and then move them to the right-hand side. Okay, so we are going to run the study. Yes, we are going to run the study now. That would, yeah. Okay, before we run the study, there are a few things that we need to ensure. Okay, first thing to ensure is that the mode up here is being set to risk and not consequence, not discharge. That is number one. Okay, number two is if we go to the combinations, okay, sorry, Okay, we leave the combinations out for now. Okay. The second one is actually to ensure that your mouse highlight is at all run rows. Okay. In order for the software to run risk and not just consequence, you actually need to make sure that the mouse highlight color is deep blue, and you will see that this is light blue and this is deep blue. So if I click somewhere else now, okay, if I click this part, okay, you will see that the deep blue changes over to this part, and this becomes light blue.
You're still on the presentation screen.
Okay. So if, oh, sorry. Yeah, I'm still on the presentation screen. Okay. Sorry. Yeah. Okay. Sorry. So let me repeat from the beginning. That is, before you run, need to make sure of two things. First one is the mode is being set to risk and not discharge, not consequence. The second thing to make sure is that the mouse highlight in deep blue color is being set at the all run rows. And if at this time, if I click on somewhere else, okay, if let's say I click at this panel, then you will see that the deep blue move from all run rows to this part. And if you click on run, okay, it will just be running the consequences for these scenarios, and you will not run the risk according to the run rows. So this is something to take note of. And yeah, if you click on the all run rows, okay, make sure that the mouse highlight is deep blue in color, and then click on run. Okay, this will ensure that the software runs the risk. Okay. So I think we shall start running the model now. Okay. It will take about 10 to 20 minutes, depending on your computer depending on your computer performance. So it could be faster, it could be slower.
Richard, this is Ilan.
Yeah, sure.
Below this all run rows, why this flammable day that run row alone in a bold font, and the rest of the things are any reason?
You see that it's in bold and there's an asterisk next to it. It means that it's the current selection. Meaning that okay, if you open current selection means that okay, you have currently selected flammable day. Okay, then when you look at the scenarios, the black scenarios is the selection for flammable day run rows, and the gray selection, the gray scenarios are the one that is not being selected by this run row.
But we have selected the all run rows, no?
Yes, we have selected all run rows. So flammable day that is in bold is the current run row. Okay, later I will show you because I'm running now. So later I will show you what does it mean by current run row.
Okay, thank you.
Okay, so maybe we'll take this time to move on because and answer any questions that you may have. Right?
Yeah, Richard, I got a question. So if the chemical has dual properties, toxic and flammable, does creating a toxic run roll now, can it still work since the run roll selects the leak scenario rather than the outcome?
Yeah, correct. Yeah, it will still work because the toxic run roll is just by name, and you have just selected the ignition sources for it, so it will still run the ignition, and it will give you the sorry, it will still work.
Richard, let me add something here. So if you, Richard, could you open another instance of Safeti? Because this one is running, you can't do anything. I want to show Liang Hong how it works in Safeti. So basically in Safeti,
maybe I change over to you.
yeah, okay. Let me share my screen. Yeah. Okay, I'm sharing my screen now. Can you see my screen?
Yes.
Okay, good. So actually, just now Richard mentioned that sometimes you want to distinguish toxic and flammable risk. In that case, you can create separate run rows for toxic and flammable. So if that's the case, what you can do is, for example, in this case, if we look at hydrogen sulfide, which is this one. So if you open this scenario, you can see here it is both flammable and toxic. So if you look at icon here, you can see it's both flammable and toxic. In that case, if you want to model the toxic risk and flammable risk separately, what you can do is here in Safeti, you can see here we have a flag. It's called type of risk effect to model. So what you can do is in toxic run roll, you can change it to toxic only. Then you can duplicate this scenario and create a separate, exactly the same models with the same data. Then you change the second one to flammable. So in that case, in your flammable run roll, you include this flammable scenario. In your toxic run roll, you include the toxic scenario. So what will happen in Safeti is if you include this toxic run roll in the toxic scenarios in toxic run roll, Safeti only calculates its toxic effect. Safeti will not look at the flammable part. Similarly, in the flammable run roll, when Safeti calculates the risk, Safeti only look at the flammable risk. Safeti will ignore the toxic part.
Okay, got it. Thank you.
Yeah.
Okay, when the model is running, let's move on and to the risk theory part. Okay, so why do we measure risk? Here is a list of the reasons that we measure risk. The most important is still showing that we have analyzed the risk and we understand what contribute to the risk. We have a good understanding of the risk level that is posed by different materials, which material has a higher risk than the other one, which process unit has a higher risk. It's mainly used for legislative compliance, safety case, plant layout and land use planning, emergency planning, non-standard operations, social responsibility, manage shareholder confidence. Okay, the risk analysis can be performed at any stage of a plant's life cycle, such as design, operation, and even during decommissioning. Okay, and why do we just not calculate the consequences? Why do we have to calculate the risk part? Now, the reason is usually high consequence events, that means events with very huge consequences, it happens less frequently than events with lower consequence. So in simple words, small events will happen more frequently, and large events will actually happen less frequently. So that is the reason why we have to account for both high frequency and low frequency. So if we quantify the risk not just by its consequences, but also include the frequency, then we have a complete risk picture. So the thing is, if we base our design only on consequences, so we may end up, our design basis will end up on the worst case scenarios. And worst case scenarios mean that we probably have to design our plant to be able to withstand the worst explosion. If the worst explosion is 10 bar, okay, that is almost the level. That is almost equivalent to a missile attack. So do we really want to spend so much money, invest so much money, and strengthen the plant to be able to withstand a missile attack? And when the event of missile attack may happen so rare that it may not happen once in a lifetime. So we probably want to mitigate our risk more we want to invest our resources at mitigating risk that happens more frequently. So that is the reason why we evaluate the risk and not just the consequences. Okay, the individual risk is the likelihood of fatality to a person at a specific location. That's why it's called location-specific individual risks within a given period of time. This is usually per year. Okay, location-specific individual risks, it means that that location, for 24 hours a day, 7 days a week, and the whole year, it's at that risk level. Okay, when it comes to IRPA, IRPA equals to the location-specific individual risk multiplied by the presence factor. If you spend 5 days a week and 8 hours a day to work at that location, the location-specific individual risk, the risk on you will be multiplied by the presence factor. So the risk on you, the risk level is higher when you go to the chemical plant to work than compare when you are at home. And then we have another measure of individual risk, which is known as the fatal accident rate. Now this number is the number per 10 to the power of 8 working hours. The definition of fatal accident rate is the fatal accident rate is X, okay, divide by 10 multiplied by 10 to the power of 8 working hours. So it's 100 million working hours. And when we come to societal risks, we have a FN curve, we have potential loss of life, we have annual fatality rates. Okay, annual fatality rates we hardly use, so we do not have to go into it. FN curve and potential loss of life is something that we use more often. So the FN curve shows a graph of the frequency versus the number of fatalities. Okay, so this frequency is the accidents frequency, and N represent the number of fatalities. You will see that for FN curve, it is standard to have 2 lines indicating the different region. This region is the unacceptable region, and this region is the allowed region. And the region below the yellow line, this is the broadly acceptable region. So if your results is in between the red line and the yellow line, it means that it is allowed, it is acceptable. But if the given chance or given the opportunity, you should reduce the risk further. Okay, if the results fall into the broadly acceptable region, then we can make a conclusion that you do not have to take any further action. But if the result fall under the unacceptable region, then you will have to keep trying to mitigate the risk until it is being lowered to the allowed region. Okay, so the workflow of Safeti from consequence to risk is that we first have an event. This event is represented by different scenarios. The scenarios is represented by having an equipment, and then we define the equipment to have different leak sizes, such as a small hole leak size or a large hole leak size, or we have a line rupture or catastrophic rupture. So that represents an event. Okay. The next thing is from this event, we will model the effect. The effect includes like jet fire, pool fire, flash fire, explosion, toxic dispersion, as well as fireball. Okay, from the effect, we estimate or we calculate the hazard zone. This hazard zone is being defined by the consequence distance of the event. The consequence distance of the effect, and the lethality that is being set, the lethality due to from this hazard zone. Let's say, for example, we know that for jet fire, a radiation of 37.5 kilowatt per meter square has a 100% fatality. And for 12.5 kilowatt per meter square, we have a fatality percentage of 50%. So that is the hazard zone. The lethality in the hazard zone. And finally, we have the outcomes. That is the hazard zone plus the direction. For jet fire, it can be it can be acting in towards the north direction, or towards the south direction, towards the east direction, towards the west direction, or towards the east direction. Or it can be influenced by the wind, depending on how frequent the wind is blowing from the south side to the north side. How frequent is the wind blowing from east to west? Because each wind direction represents a different frequency, so we would expect that that the risk level at different locations to be different, simply because the wind is blowing at a different frequency. So from the events to effects, okay, from event to effect, we apply the event tree. In the event tree, we have an ignition or we have no ignition. What is the possible outcome if we have an immediate ignition? Or what is the possible outcome if we do not have immediate ignition, but we have delayed ignition? So from no immediate ignition, we have delayed ignition and no ignition, and the outcome is flash fire, explosion, or even with a delayed ignition, there is no effect. There is a possibility that it has no effect because perhaps the concentration level of the gas cloud is below lower flammability level, so it does not even, it has encountered an ignition source, it will not be ignited. And then from the event tree, we get the effects. Okay, the effects are referring to jet fire or explosion or flash fire or pool fire. So the effects would give a consequence hazard, would give a hazard range. Okay, and then from the effects to the hazard zones, let's say, for example, the radiation. Okay, we understand that this is, let's say this is a fire radiation, and the red color is representing a radiation level of 37.5 kilowatt per meter square. Okay, then the second circle, this is representing the radiation level of 12.5 kilowatt per meter square. And then the third circle is representing 5 kilowatt per meter square. Okay, and we established that 37.5 kilowatt per meter square has a 100% fatality. So if anybody is within if anybody is within this red color zone, okay, it is confirmed that it's a 100% fatality. There's no chance of survivability. But if anybody is located in this orange zone, okay, the fatality in this zone is the average of the outer circle and the inner circle. So if 12.5 kilowatt per meter square has a 50% fatality, okay? So the average of 100% and 50% is 75%. So the fatality in this zone, orange zone, is 75%. And if, let's say, 5 kilowatt per meter square has 1% fatality, so the yellow zone has an average fatality of the average between 50% and 1%, and that is 25.5%. So this is how the software will actually establish the hazard zone from a jet fire or from a radiation. Then it will calculate the fatality inside different zones. Okay, and then next we look at the explosion. Here is some explanation about the consequence. This is supposed to be covered by FAST, but nonetheless in Safeti we still cover a little bit. Okay, so for explosion, we are using different explosion models. One of the explosion model is the 3D cloud AMI purple book explosions. Okay, and the unconfined explosion strength and explosion efficiency values, okay, is by default, it has an unconfined explosion strength of 10 and explosion efficiency of 12.5. And from these parameters, we will be able to generate the overpressure in bar. Then in the outdoor vulnerability, we set the 0.3 bar to have 100% fatality. And in the indoor vulnerability, we set another overpressure level, that is a 0.1 bar to have a 2.5% fatality. Okay, so we have outdoor, if we can visualize the vulnerability hazard zone. Okay, so for an explosion, the fatality up to the explosion radius of 0.3 bar is 100%. And outside of the explosion radius of 0.3 bar, the fatality is 0%. Okay, then we have the indoor vulnerability, and then we have the 0.3 bar. And then we have, okay, the explosion overpressure is slightly different from the radiation because the radiation hazard zones, we take an average of the inner circle and the outer circle. But for explosion, we do not do that. So if we are in the zone in between 0.3 bar and 0.1 bar, the fatality is 2.5%, and it's not the average of 1 and 2.5%. So the fatality here is 2.5%. Yeah. So this is how the software would handle explosion fatality. Yeah, in the zone of 0.3 bar and 0.1 bar in between, the fatality is defined by 0.1 bar, and that is 2.5%. Okay. Okay, then the ignition probabilities. When a flammable cloud is released, it will ignite if it encounters a source of ignition. The immediate ignition probability is governed by the settings in the risk tab. The delay ignition is handled by presence of ignition objects on map. So so this is normally what we define the delay ignition objects on the map. We can define a polyline, a point, or rectangular area, or polygon area. Okay, so where the gas cloud covers part of the polygon area. Okay, so this ignition probability for the entire polygon area will also be divided by the area. Okay, and this will modify the ignition probability factor. And if let's say the gas cloud didn't fully covers the whole ignition polygon area, so the ignition probability would be the ignition divided by the area. Sorry, area covered. It's better to write this. And then we come to the toxic impact modeling. For toxic impact modeling, for toxic only materials, okay, it's only one effect model, no event tree needed. Once it's being released, then it will start to have the toxic effect. So depending, okay, let's say this is the release source and this is the area that is reached by the toxic dispersion. Okay, so depending on the concentration and the exposure time, the probability of death will be calculated based on the concentration and as well as the exposure time. Okay, then a different location, because let's say this area, it probably represents a concentration level, and you may have a larger circle that represents a more diluted concentration level. That will represent a different probability of death. So all these results will be integrated together to give you the final probability of death. So if we imagine the effect zone of the outcomes of the different outcomes as like a flower petal. Okay, so this is like a flower petal, and each flower petal represents the maximum distance of the hazard zone. Okay. Then we would combine all the flower petals together. Okay. So when all the flower petals are combined together, and you see the grid that is below, each grid will have a total risk. Okay, let me continue explaining this risk grid. Okay, so we have the grid that is below. The grid is of a certain size. This could be 1 meter times 1 meter. Okay. Okay, so of the hazard, all the hazard zone, whether it's whether the horizontal jet fire has a further hazard zone than the than the vertical jet fire. Okay, when it adds up together, the maximum that is being reached Okay, the furthest hazard zone will be defined by the event that has the largest effect zone. Because if let's say this is 5 meters and this is 3 meters, okay, when it adds up together, it doesn't mean that you will have an 8-meter consequence distance. That is something just to clarify. So when this all adds up together, okay, so each grade would have a specific risk level. Okay, so each grade would have a specific risk level. So let's say this grade, it has 3 times 10 to the power of -5 per year risk level. Consists of all these events, and perhaps this grade has a 5 times 10 to the power of -6 per year risk level. So basically, when all these hazard effects are being combined together, it will give every risk grade a value of the risk level. Okay, and now we come to outcome vulnerabilities. Okay, the outcome vulnerabilities. Okay, vulnerability categories are listed in the risk tab. So the risk tab which we insert the nation and the population, below it is the vulnerabilities. And by default, we have 2 vulnerability standard. One is outdoor vulnerability, and the second one is the indoor vulnerability. The lethality posed by each outcome is a factor which is multiplied by the vulnerability, so as to govern how much a pure hazardous outcome affects people in the real world. Vulnerabilities are defined for indoor and outdoor for each hazardous outcome. Values are taken from Dutch Purple Book. To be precise, is actually BAVI. So the default values are taken from BAVI. And users, if you have alternative values, you can replace the values in the software. So separate vulnerability factors are used for each effect type: the explosion, radiation effects, flash fire vulnerability, toxic vulnerability. Okay, lastly, we have the risk array. That is, each grid is representing a different risk value, which is why the location-specific individual risk, you would have a different risk level at different location. That is because with all the hazard outcomes being added together, and also because of the weather probability, the frequency of the wind blowing from north to south is different from the frequency of the wind blowing from east to west. So because of this difference in wind probability, difference in hazard outcome consequence distance, so the different location will have different risk level. And we tabulate all these risks into a risk array. So we have all this risk array, and when you need to generate the results, okay, we will just depend on the risk array and we will draw the circle. Okay, we have a question. Are we supposed to have a short break? Aiden, what time is the next break?
Hi, sorry, it's actually 2:30, so we can go for our break now.
Oh, okay. So 15 minutes break, right? So we would come back at 2:50. No, 2:50.
Cool, thank you.
Hello again. So it's 2:50, and I hope everybody has a good break. So let's come back to the presentation slides as we finish the last part of this risk theory, that is the impact on the population. Okay, so previously we have talked about we have talked about how the software started calculations from an event, from the scenario that you define. Then the consequence calculation part will generate all the possible effects and to also calculate the extent of the hazard zone. And then Safeti will subject the hazard zone to wind or directional probabilities. And the next thing that the Safeti will do is to calculate the impact on the population. So after having the hazard zone effects, after having the hazard zone results, now Safeti will use the hazard zone to calculate the impact on the population. Now, depending on the population, whether it's a point or whether it's a rectangle or whether it's a polygon, for point, it is a very straightforward whether the population is being reached by the hazard zone or not reached by the hazard zone. However, for rectangle and for polygon, because the rectangle and the polygon actually it covers a few boxes in this grid, so it's possible that the hazard zone may partially cover part of the population. So this is when the density of the population is being calculated in order to calculate the area that is being covered by the hazard zone, and this is multiplied by the density to find out how many people in the covered area are being impacted by the event. We need to take note that the population will also act as a weak ignition source. A weak ignition source, that meaning that it is an ignition source that has a low probability of ignition. And this ignition probability can be found in the software. Okay, so before I move on to the software, okay, sorry, just give me 1 minute in order to find out the population omega factor. Okay, so let's switch to the software screen. Okay, if we click on the parameters tab and then double click at the flammable parameters. Okay, double click at the flammable parameters and then at the flammable risk. And then scroll down until you see the flammable risk. Okay, so we have a population omega factor that is 0.000168. So it's a weak. The population act as a weak ignition source. because it has a low ignition probability. After the impact of the population, now it's time to look at the risk results. By now, I hope everybody has finished running their models. Okay. So has anybody not finished running the models? Okay. So first of all, we have to talk about the combination factors. So in the last exercise, we have split the run rows into 4 run rows. We have flammable day, flammable night, toxic day, toxic night. So in order for the software to combine all the run rows to generate a single integrated results, we would need to use the combination factor. And combination factor is basically for you to assign the factor that you assign for each run row. Now, because we know that although we have split flammable run row to run flammable models and toxic run row to run toxic models, okay, but 2 run rows running 1 model. Now, this when I say 1 model, is actually I say one type of model, because we have the flammable day running the same model as the flammable night. So we will need to assign 0.4 or 0.6. Well, as long as the 2 of these run rows add up to 1, you can also assign 0.5 and 0.5 to these 2 run rows. Okay, as long as these 2 run rows add up to 1. Okay, so that it will assign because it has repeatedly run the same model 2 times. So you will need to split them into half-half, or 0.4, 0.6. The same goes for toxic run rows, toxic day and night. So you would actually need to assign a factor to toxic day and toxic night, because these 2 run rows run the same model repeatedly. So it's better to split them into 0.5, 0.5, or 0.4, 0.6, as long as they add up to 1. Now, it's possible also that you do not want to add up to 1 and you put 0.2, 0.2. Then the final results will actually be lowered by a factor of 0.4. Okay, and so the combination allows you to the combination actually allows you to show only flammable results by switching off the toxic run rows by putting them as 0. So the final calculated risk results will be multiplied by 0, and it will become, so it will not show any toxic results for these two run rows. Then you can also switch off the flammable run rows and show only the toxic run row results. Or you can have a total risk results that is combine all the 4 run rows. Just take note that the combination, the software can only allow up to 20 combinations. So the more combinations you have, the slower that the software will run. So let's do an exercise that is to define 3 combinations in Safeti. As you see in this screenshot, we are going to define the flammable day to have a 0.4 and the flammable night run row to have 0.6. And we have also 0.4 for toxic day run row and 0.6 for toxic night run row. So in this case, the night time is longer than the daytime. So in the day, 24 hours, 60% of the time is in nighttime, there is no sun, and 40% of the time there is sun. So this is why flammable night has a higher factor than the day run row. Okay, so if we move back to the software screen, so let's go to the combinations super tab. This is the combination super tab. We click on it, okay, and then we click on add. So you have a new combination number 1, and change the name to flammable risk. And assign 0.4 factor for flammable day and 0.6 factor for flammable night. And keep the toxic day and toxic night run rows to be 0. So we add another combination. And then we input 0.4 for toxic day run row and 0.6 for toxic night run row respectively. So we add a last combination and name it as total risk. And input 0.4, 0.6, and 0.4, 0.6. Okay, last but not least, check the box for use all combinations. Now, in order to check whether your model has finished running, it should have a green tick at the icon for all the run rows. For all 4 run rows, it should have a green tick. So that should mean that results are available and we can view the risk results. Just now, to answer the question, what does it mean by having a run row in bold and in asterisks? Okay, so if you can see that flammable day that is currently being selected, okay, what we see here is that the HCU, HPU is black and the SRU, ammonia storage and chlorine storage are being grayed out. So this is the selection for this run row, okay, flammable day. And if we double click at the toxic day, okay, then you will see that now the bold and the asterisk has moved to toxic day. And in this run row, the selection for this run row is SRU, ammonia storage, and chlorine storage, while the rest of the models are being gray. So this is the selection for toxic day. So we are able to choose, we are able to double click at one run row and see what is the selection for this run row. Okay. Okay, the next part is we are going to look at the results. So before we look at the results, let's just look at slides. Okay. When we look at the individual risk results, you can see that from this risk button here, okay, you have 4 rows, 1, 2, 3, 4. Okay, and it can be divided into individual risks and societal risks. Okay, so it can be divided into the upper part showing individual risk results and the lower part showing societal ranking results. Okay, and then now let's go back to the software. We are ready to look at the results. First, we would, okay, my software is showing explosion details and fire details. This is not available for some of your software, okay? We would, this is to show the explosion details and the fire details. This would require 3D explosion extended license. Okay, but nonetheless, you would still have the multi-level, the multi-row, and the multi-vulnerability. So we start first by looking at the multi-level results. Okay, we can click on multi-level. And in this panel here, these are the risk levels that we have set up earlier on in the risk preferences. Okay, and then the next thing is here, we look at the selected run row or combination
and the selected vulnerability, you will need to define whether you want the results to be just this run row, the flammable day run row, or the flammable run row, or the combination. So I would choose total risk because I want a contour that combines both toxic risk and flammable risk. Okay, as for the vulnerability, I have currently chosen outdoor vulnerability. We first look at the outdoor vulnerability results. Okay, that means the risk results that is being shown later on will apply for people who are outdoors. So we click on next, okay, and then you can save this results selection. You can give a name to this result selection. It's combined risk. It's giving me a lot of problems there. Okay, I will just choose A and click on finish.
Richard, can I ask a question? Sorry, I think you might have to explain something. Hello?
Yeah, please go on.
Just now you had put in a combination risk. Now, where do you get? I wasn't able to insert a column next to the flammable risk actually.
Yeah, you need to click on at the combination tab. You will need to click on this icon.
Oh, okay. It doesn't happen automatically. Okay, I get it now. And could you show what are the values again? Toxic risk. Okay, toxic risk. And is there any other column over there?
Yes, there is. So there are altogether 3 columns. So the first one, flammable risk, it has a factor of 0.4 for day and 0.6 for night, and 0.0 for toxic. Then for toxic risk, it's the reverse, and then for total risk, you add up together.
Okay.
Yep.
Sorry, it's not very user friendly.
Okay, in the results that are generated, we are able to see the different color contours, Okay, so the largest contour is 1e minus 8, and the smallest contour is 1e minus 3. And 1e minus 3, now, if you do not want the population or the ignition objects to interfere with your interpretation of the results, we can switch it off. So you can come here to the legend panel that is at the left-hand side and right-click at the populations and choose display off. So this will switch off the population. And next thing is to right-click at the ignitions and click on display off. So switch off the ignition. So if you want, you can further on to switch off the equipment and switch off the risk ranking points as well. So this will allow you to have a clean map where you can only see the risk results. You will see that, okay, so the highest risk is 1e minus 3, and the lowest risk is 1e minus 8. But 1e minus 8 also has the largest area, okay? And we can see that what risk level has already extended to the residential area. We can see that that is 1e minus 5 extending to the residential area. Okay, so this is multi-level. Multi-level shows you the results. In this case, it's combining both toxic and flammable. And it gives you the risk level, the different risk level from 1e minus 3 to 1e minus 8. Okay, let's take a look at another multi-row results. Okay, multi-row results. Okay, multi-row results. It allows you to show the risk contour for this run row, for flammable day, flammable night, toxic day, and toxic night. So it split the run rows. It split the contours into 4 contours, each representing a run row. And you will need to define the risk level and the vulnerability. So for the vulnerability, we keep outdoor vulnerability. And for the risk level, we put 1E minus 6, right? And we just choose next and just finish. Okay, so here you will be able to see the contours of the different run rows. First of all, allow me to switch off the initial objects and the population so that it does not affect my interpretation of the risk contour results. Okay, we have the largest contour, that is the orange contour, and it is a toxic night. It is representing toxic night run row. And then we have the toxic day run row represented by the green contour, the lime green contour. And then we have the flammable day and night represented by the blue and the very dark red color. So from this, from the results, we are able to immediately judge that the toxic risks are higher than the flammable risks, which means that the toxic results are way higher than the flammable results at 1E minus 6 risk level. We can't tell for the higher risk level like 1E minus 5 or 1E minus 3, 1E minus 4. We don't know yet, but at one glance, we are able to see that toxic risk results are a lot higher than flammable risks. So which means that if we are to target, if we need risk mitigation measures, we should target toxic models. So this is how you can use a different method to display the results, and it provides you with the convenience of interpreting the results. Okay. The next thing is let's take a look at multi-vulnerability. So multi-vulnerability, as we only have outdoor vulnerability and indoor vulnerability, there are no other vulnerability standard being set for this exercise. So we just use these 2 vulnerability standards. And the risk level is selected as 1E minus 6. And we need to choose a run row or combination. So it's always good to choose a total risk combination. Okay, and click on finish. So basically the function of the result selection is allowing you to filter out results that you do not want and display only results that you want. Okay, so we have 2 contours here. The larger contour, which is represented by the blue contour, is the outdoor vulnerability. And the dark red contour is representing the indoor vulnerability. And we can see that at 1E minus 6 risk level, the outdoor vulnerability has a larger area than the indoor vulnerability. Okay, so how can we make use of the indoor vulnerability results? It means that at 1E minus 6 risk level, if I have a building inside the indoor vulnerability contour, I am not safe. So the building inside the indoor vulnerability contour is if I'm in that building, I may not be safe at 1E minus 6 risk level. Okay, so after looking at the different individual risk contour selection, we have multi-level, multi-role, and multi-vulnerability. So let's take a look at the risk ranking results. So we are now going to generate the results for IR, which is individual risk ranking, and the details of it. Okay, these results are extracted using your risk ranking points. So first, let's take a look at the IR ranking grid. So in the result selection window, we are able to choose whether we want a single run row or we can have a combination. And what I would always do is that I would like to have the total risk. Okay, combine the total risk together so that I can have a full picture. Then if I click on next, I can even choose what scenarios that I would like to include, what scenarios that I would like to exclude in the risk ranking later on. Okay, then we click on next. And these are the different effects. Okay, so these are different, you see the different programming code here, CNIBO. It represents continuous release, no rain out, immediate fireball. So the outcome is actually a fireball, and it's generated from a continuous release scenario. The scenario is likely a gas because it has no rain out, and it's generated by immediate ignition. Yeah. So all these codes, it tells you how is the outcome being generated. Okay, and then you can, if you keep on clicking on next, you will come to this point where you can select the risk ranking points that you would like to see the results, and you can filter off the risk ranking points that you do not want. So in this case, I would like to remove site. I just keeping control room, chemical plant, office, West Town and East Town. And I click on next. I can even choose whether I want to have both outdoor vulnerability results and indoor vulnerability results, or I just want to have one of them. So lastly, I click on finish. And what appears is this screen. And I can click on this arrow. Okay, and I can click on the control room. I first start with the control room. I will be able to see what are the scenarios that contribute to the risk at the control room according to the outdoor vulnerability standard or the indoor vulnerability standard. Okay, so the first column is giving me the model name. This is the scenario. It shows you this is from a chlorine storage, the chlorine tank, and it's a medium leak scenario. These are the coordinates. Okay, you can ignore the location index because this is a programming language. So just ignore the location index. And you can see the model frequency here. The model frequency is the event frequency or the leak frequency that you input into the scenario. And you will be able to see from the model frequency to the total risk. Okay, this model frequency to total risk, it has multiplied with the weather probabilities or direction probabilities, ignition probabilities, and etc. So it gives you the final risk. Okay. And the percentage risk is how much does the risk contributed by this scenario compared to the total risk. So you will see that this scenario has already contributed 41% of total risk. So if I target this scenario and I employ or I apply certain risk mitigation factors, the most risk reduction I can achieve is 41%. Probably this will tell you, is it worth doing it? Because if this risk is, let's say it has a very large percentage, then I would think that it's possible, it's probably good to target on this scenario. If let's say the risk is only 7% of total risk, then I may think that it's not worth spending the effort. Okay. So now, and the last column, what is the risk divided by the outcome? It's basically the total risk divided by the model frequency. The risk divided by outcome, it means it gives you a sense of how serious is the consequence without considering the model frequency. Okay, so we know that the risk is being calculated by multiplying frequency with consequence. Okay, in this sense, the frequency plays a part in lowering the risk. If my frequency is low enough, my risk will be low enough too. But if without considering the frequency, how serious or how severe is this scenario? I just use the risk to divide by the frequency, and the larger the number, the larger potential that this scenario has in causing a large consequence. Okay. So we can tell that the first scenario contributed 41% of the risk, and the second scenario contributed 23% of the risk. But if we disregard the frequency, actually the second scenario has a more severe consequence than the first scenario. So this is how we interpret the results, and this is the use of this parameter risk divided by the outcome. Sorry, can somebody who has not muted yourself, because I'm interrupted by a phone ringing sound. Okay. So with the same way, you can examine the results for other risk ranking points such as chemical plant, office, West Town, East Town. Yeah, and okay, this is opening one by one. Now, if you want everything tabulated in table format, you can choose IR ranking details. So I click on the risk and then IR ranking details. Okay, and I am able to choose either I want individual run rows or I want a combination. So I choose the combination total risk and click on finish. So now I will have everything tabulated in table format. So this table format can be exported to Excel for your post-processing of results if you want the raw data. So this gives you the data tabulated in table, and you can export to Excel for your further processing. Okay, let's move to the presentation slides now. Okay, so we have, okay, I just go through the slides very quickly. So we last stopped at this slide. So the next slide is showing the individual risk contours. The individual risk contours can be multi-role, multi-level, or multi-vulnerability. And yeah, for multi-role, you will need to define the risk level as well as the vulnerability. For multi-level, you will need to define the run role or the combination or the vulnerability. For the multi-vulnerability, you will need to define the risk level and the run role or the combination. Okay, we have also gone through the risk ranking grid. So I've explained what is total risk, percentage risk, and risk per outcome. I've also gone through the individual risk ranking grid. And then the individual risk ranking details is tabulating the data in table format. Okay, now we come to IRPA, because it's not reported in Safeti directly, so we have to use IRPA. We have to get IRPA by applying a formula. That is LSIR multiplied by the hours per day and the days per year, and divide by 24 hours times 365 days per year. So that will give you the IRPA. And the LSIR can be extracted by risk ranking points. Oh, okay. So we are coming to the risk question, the quiz question number 2. So let's get ready. Let's get ready. Okay, Maddie, you are getting slightly different graphs, and that's okay. That's because depending on your IT environment, and also if you have, if you open the model that is from the handout, or you are using the model that you built on earlier on, so that will give you slightly different results.
Yeah, I'm getting very, very different results. Can we?
Okay. Are you using the model that you built, or are you using the model from the handout?
I'm using the last save of it was the RRPs, so.
Okay, you are using the RRP.
Yeah, that I've built up from there, so.
And the version of the software that you are using, 8.23, latest version, right?
8.23, yeah.
It's a bit difficult to check what's different now.
With what is it, file number 8, the risk results one, if we use that?
Yes.
Is that what the
I suggest everybody use number number 8, the study file number 8, because during this training, when you build the model, when you type the input, maybe there are some data different from the one we in our handouts. So if you use different input, the result can be different, which will result in wrong answer in the quiz. So I suggest everybody open number 8 and which already.
I'm just thinking, if we go to number 8 though, will we have to run it, which could take, 10 to 15 minutes to run? We might not have time. Before mine took about 15 minutes to run, so I'm just worried about opening up number 8.
And actually for number 8, the result is already stored there. So when you open it, you should get the results. Yeah.
Okay. Yep.
No worries, because number 8, the results are already completed. And allow me to introduce you to a function known as the export workspace. Now, because we do not, there is in daily life, it's possible that we will need to pass on our model to another person. Okay, so what if another person gets our model and run it, but probably he has a different setting, then he get different results. So let's click on File, and there is a function called the export workspace. Now, this export workspace is a very powerful function because when you click on the export workspace, you can select to export the risk results, map images, the materials data, and the parameters data. So you would basically export all that you have done, all of your work, before passing it on to another colleague. So when the other colleague opens your model, which is an exported workspace, he will get exactly the same result as you. So there will be no question. So we will eliminate the possibility of having different results, inconsistent input data, or the different possibilities that we may have and getting a different result. Okay, so whenever you need to pass on your model to somebody else, we always recommend you not just to save the workspace, but export the workspace. Okay, so the results are already available for this last model from the handout. Okay, so the next thing is to answer the question. Let me just take a look at the question. Okay, so for this question.
Sorry, my results don't seem to be coming up. Can you just check that you can actually see the results on that?
Again, sorry?
So my results aren't coming up on that workspace 8. I had to re-put in the raster image set.
Ah, okay.
And the results are...
Yes. Yes,
there are
yes.
two 8 files. I don't know if you've seen that. One of them is study with risk results.
Oh, yeah.
Todd, can I confirm with you, is this number 8, it should be an exported workspace, right?
Yes, you can see when you open the study, the risk is enabled for you, which means the result is available.
Your raster image set should also be there because you do not have to redefine the path for the raster image set. So,
okay.
Yeah.
I opened up the one that just says risk results, not study with risk results. I'm assuming it's the study with risk results is the one that we want?
Yes.
Yes.
Yep.
Okay.
Let's open this number 8, Safeti Training study with risk results.psux. Okay, just to make sure that you have the risk button activated. Now, I do not want anybody to not able to generate the risk results and then not able to answer the quiz questions, okay? So the risk button here, okay? Now, for the second question, the quiz question number 2, I will give you slightly more time because I know that you will need to generate the results before answering the question. So you would have 1 minute, okay, 1 minute to answer question number 2. So, and here we go, question number 2. Okay, what is the highest level of risk at the site boundary? Yeah.
Richard, I'm seeing your slide presentation, not the whole page, the selection page.
Yeah. I have already shown you how to generate the results. So now I'm showing the quiz question, and you are supposed to generate the risk result, look at it, and answer the quiz question.
Yeah. Richard, I understand the question. My point is, the earlier question appeared as a selection tab. I can select A or B or C. Now my screen, it is showing only your slide, not the selection panel.
Yes, that's giving everyone 1 minute to answer the question.
Okay. I will wait for it then.
Richard?
Yes.
Yeah, the questions is where the risk touch the boundary of the sites, right?
Yes. So the keyword here is highest and at the site boundary. Okay. Okay, we are closing the polls and I'm showing the results. So, are you able to see my slide?
Yes.
Okay. Okay, what is the highest level of risk at the site boundary? Okay, I hope you have no problem in identifying the site boundary. The site boundary is basically somewhere here, okay? Okay, so how do we answer this question? Now, first of all, we look at the highest risk level is you have 0.01 and you have this 1e minus 3. That is this red color, but it has not reached the site boundary. Now, in fact, the site boundary is being covered by 1e minus 4 and the orange color 1e minus 5, and also the So the largest contour is 1e minus 5, but we are asking about highest level, so it's 1e minus 4. So the answer is A, 1e minus 4. So if you take at any point, okay, here or here, the highest level is 1e minus 4. Okay. Okay. Now for risk level 1e minus 6 per year, which risk type covers a larger area for outdoor vulnerability? And the tip here is to generate the multi-row risk contours. And you have a selection of whether it's toxic risk or flammable risk. Okay, so again, we have 1 minute to answer this question. Okay, and I'm going to, have you understand the question? Because once we launch the poll, you will not be able to see the screen. Okay, so I hope you have understand the question. Okay, let's launch the poll now. Okay. Okay. All right, so let's take a look at the answer. Okay, if you generate a multi-row and then set the risk level to 1e minus 6, okay, for toxic risk and flammable risk, you'll find that toxic risk will have a larger area. Okay, if I do it in the software, how should I do it? So for this, let me show you. Okay, the correct steps to get the results. Okay, so in this risk button here, we click on multi-row. Okay, then the next thing is we remove all the individual run rows, but we have the combinations, flammable, toxic, and total. Then we have the risk level 1e minus 6 and the vulnerability, outdoor vulnerability. Okay, then we click on finish. So this will show you that the toxic risk, okay, because the red color one, the dark red color one is the toxic risk and the blue color one is the flammable risk. The toxic risk has a larger area than the flammable risk. Okay. Okay, here comes question number 4. So I would like you to get ready. Okay. Now, once we launch the poll, you will have 20 seconds to answer the question. Okay. So when I show the question on the screen, then you can start to generate the results. Okay, let's move to show the question number 4. Okay, for risk level 1E minus 6 per year, which vulnerability covers a larger area? Is it the indoor vulnerability or the outdoor vulnerability? So the tip given here is that you should generate the multi-vulnerability risk contours, and not to forget that the risk level is being set at 1E minus 6. Okay, so you have 10 more seconds to look at the question, understand the question before we launch the poll.
Sorry, for this one, is it for flammable and toxic, both, or for which one?
Yes, it's for both. So we did not specify it's for flammable or toxic, so it's for both combined. Okay.
Okay.
Yeah. So if you have any questions, it's better to ask now. Yeah. Because once the poll is launched, you will have to immediately make a choice to answer the question. Okay. And okay, so the poll starts now. Okay. So it's time to show the results. Yeah, it's the outdoor vulnerability. Okay. So how do we get these results? Let me show on the software. You get the multi-vulnerability. So you have outdoor vulnerability and indoor vulnerability. The risk level is 1E minus 6. The only thing is you need to be careful that the run row or the combination, you should be selecting total risk instead of flammable risk or toxic risk. You should be selecting total risk and click finish. Okay, so what you see here is the blue circle is definitely larger than the dark red circle. So the blue circle is outdoor vulnerability. So the answer is B, outdoor vulnerability. Okay, here comes question number 5. So get ready to read question number 5. Okay, so question number 5. What is the LSIR per year for control room indoor vulnerability? Okay, so the risk ranking point is control room. Okay, and then the indoor, it's we want indoor vulnerability, and then the LSIR per year, this is referring to risk. Okay, so you can choose between 2E minus 4, 6E minus 4, or 2E minus 5. This is not generating the contour. This is generating the IR ranking grid. Choose the closest one. Okay, choose the closest one. Okay, so, okay, does anybody want to ask question about this question before we launch the poll? So everybody understand the question, right? Okay, so let's launch the poll now. Okay, so let's show the answer. And the answer is A, 2E minus 4. That's because if you generate the IR ranking grid, you'll be able to see under the control room and indoor vulnerability, the risk total is 1.8 E minus 4, and it's closest to 2E minus 4. Okay. Okay, let me show you on the software how do we get it. Just want to make sure that everybody gets the correct way of getting the answer. So at the risk button here, we click on the IR ranking grid. Again, we want to combine risk of toxic and flammable. So let's remove the flammable risk. And then we want only for control room. So I will remove all the rest of the risk ranking points, leaving only the control room, and then click on finish. So here I will be able to see that the indoor vulnerability is 1.8 E minus 4. So the answer is 2E minus 4. And the next thing is I'm going to show question number 6. So let's get ready for question number 6. Okay, the question goes by, which scenario contributes to the highest risk to the control room indoor vulnerability? So that means you do not have to close your window. You can continue to expand what you have got, what you have got just now. So the key word here is the highest risk, not frequency, not risk per outcome, risk. Okay. Okay. So if there is no further question, we will launch the poll now. Okay. So the answer is, all right, it's hexane loading area, medium, C.
Hi,
Okay,
Richard.
Yeah.
Hi, Richard. Sorry, I'm having a problem generating the IR ranking grid. It doesn't show up as anything. So I'm not able, like the last two questions, 5 and 6, I wasn't able to answer them because it didn't generate results for me.
It didn't generate results for you. Okay. Can you tell me if your risk button is activated?
Yes, I selected the IR ranking grid from the individual. Yeah.
It doesn't show up. It means that you get a blank screen.
So I went through the selection process of selecting the control room and everything. And then when I say finish, it doesn't give me the tabular data that you see on the screen right now. It shows
what do you see then?
Nothing.
So it's
just
a blank screen.
Yeah, and I selected total risk. I unselected combination and flammable and selected it only for control room. So I'm not sure what happened.
Okay. Does anybody else have the same issue that you cannot see the results?
I can see them.
Yeah.
Okay.
Is there a row there that says total risk in combination next to it?
Yep. It's total risk. So
Yeah.
I'm not
Yeah,
particularly asking just flammable risk or toxic risk alone. Okay. So what I will do is okay. Later.
If I'm not able to rate the result, I can't possibly answer the quiz.
Yes, understand. So yes. Okay. So don't worry about it first. Don't worry about it first.
Okay.
We would solve your problem, and I know it's regarding the certificate. Okay, but we would likely exempt you from this. I mean, as in from the questions.
I'm actually running chapter 8 with the risk results, and like I reopened that file and I ran that file again. So I'm not sure why it's not generating it. It was generating the risk contours, but not the IR grid risk.
Okay. We will have to look into your problem later on. Okay.
Okay.
But right now, let me carry on with the training first. So let's. Okay. Don't worry. We will make exemptions as necessary. Okay. Okay. But I just hope that you know the steps to get the results. Okay.
Yeah.
For now, I will show. I will still show how do we get the results. Okay, so let me change my screen to the software screen. Okay, just now we are stopping at this IR ranking grid. Okay, and then can you do one thing for me? That is, if you have a lot of windows above there, can you close them? Sorry, if you have a lot of tabs above this space, can you close them? Okay, so what you need to do is just to expand the indoor vulnerability. Actually, I will advise everybody, if you have a lot of tabs up here, and each tab will consume your memory. So if you have too many tabs above here, then when there's insufficient memory, you will see blank. Or simply the software couldn't display the results for you. So I would advise you to close the previous tabs. Okay, there's a cross here, so just close it to save memory. Okay, once you have expanded, okay, what you need to do is actually at this risk, you can just click at the column heading, okay, and you would see a small triangle facing downwards. Okay, this is to rank the scenarios according to the risk. So here it shows you immediately the highest risk. Yeah, in order for you not to look at the wrong, sometimes the first scenario that displays here is it may not be the highest risk. So what you need to do is you can click on this total risk column, and then so that it will rank the highest risk to the lowest risk for you. And then we now know that the first line is the highest risk. And then we expand this model to see what is it. It's the hexane loading area medium. Okay. Okay, so the next question, we are going to generate the risk ranking results for another risk ranking point. All right. And it's the same type of question. We are going to ask you which scenario contributes to the highest risk. Okay. If you are still having the same problem that you cannot see the results, even after closing the tabs above, is it?
Yeah, same problem. Not sure what's going on. maybe we can discuss later on.
Yeah, okay. In that case, yeah, okay, but for the rest, you have no problem, right? So let's show the quiz question now. Okay, which equipment contributes to the highest risk to West Town? So it's West Town, and still it's the highest risk.
Richard, is it for indoor or outdoor vulnerability?
Oh, good question. Let me see.
The fact is that I'm getting the same result for both the cases. Anyway, I'm just for clarity, I'm asking.
Okay, but let me just hide the question for a while. We do not launch the poll results yet. Okay, so let me just okay. Because we did not specify, so it's outdoor. Okay.
Okay.
It's outdoor vulnerability. And I apologize for the lack of clarity in the question. Outdoor vulnerability. Okay, so let's launch the poll now. Okay, and the answer is okay. Now the answer is chlorine tank, and we look under outdoor vulnerability. So you will see that because the chlorine tank actually tops everything. So the first field is all chlorine tank. So I hope that there is no way for you to miss this. Okay. Okay, let's take a look at the software. How do we exactly, what are the steps to generate the required results? So let's click the risk button.
Richard, sorry to interrupt again. I tried generating again with all the tabs closed. It's blank. By selecting West Town. Yeah, just to let you know. Sorry.
Okay, it's okay.
Yeah.
Yep. Noted. And we will deal with the problem later on. Okay, so that's so we will choose a total risk, and then we click on next. Okay, and I want to filter all the rest, leaving only the West Town, and click on finish. So expand the West Town. Okay, so what you get here is basically the scenario that is contributing to the risk at the West Town is all chlorine tank. So there is no other equipment here. So I hope that this is very straightforward chlorine tank and not other equipment. Okay. We are coming to question number. Okay, not yet. So now I will go into the societal risk part. Okay, and we are now almost 4 o'clock. So we would. I'm sorry that we are overrunning. So we will need another 1 more hour. Okay, by 5 o'clock we will finish. Okay. Sorry for overrunning. So now we are going into the societal risk results in Safeti. What you see here is you have the SR ranking grid, the category PLL, the FN totals, and FN details, the smooth FN and the raw FN. So to look at the FN curve, we would either choose smooth FN or raw FN. The difference between smooth FN and raw FN is that the two of them actually are calculated slightly differently. Both apply different methodology to calculate the results. So it's not surprising to see that smooth FN is and raw FN, they do not exactly match each other. Okay. If you ask me which one would I recommend you, I would recommend raw FN, because raw FN, you are able to manipulate with the results, meaning that you are able to filter off certain scenarios. If you have a FN curve that is not meeting the risk acceptance, that is not meeting the criteria, then you can easily filter off some of the scenarios and see if the FN curve would be lowered down. Okay. So it has a more powerful function than the smooth FN. Later on, I will show exactly what are the differences between the raw FN and smooth FN. And I will also show you SR ranking grid and category PLL. Due to time constraint, we will leave out FN totals and FN details for now. Basically, these two options are tabulating the data in table format. It's not anything different from SR ranking grid and category PLL. Okay, so for the FN curve, we have the minimum and the maximum risk criteria. Then we have the result. The result is represented by this. We can have a single curve that is combining both flammable risk and toxic risk, or we can split it into individual run rows. Okay, just like this, we can split into 4 curves. Okay, and the smooth FN curve is calculated using predefined ranges of fatality numbers like 1 to 2, 2 to 10, 10 to 100, and 100 to 1,000. Smooth FN is based on total results for the run row combination without any details recorded about which model, whether types of effect contributed to the risk level in a given range of n. So which means that for the smooth FN, you will not be able to find out, let's say for example, now I have 2 curves that is out of at the unacceptable region, and I would like to find out which are the scenarios that contribute to the FN curve being out of bound. For smooth FN, I'm not able to do the filtering to know which model, which weather effect, which weather or which effect contribute to this to these results. But for raw FN, I'm able to do so. Okay. Now let's take a look at the software. So if you go to the risk, okay, click on the risk, and then click on smooth FN. Okay, and I would like to have a total risk combination, not just a flammable risk. So I always have to do this action of removing the flammable risk from the right-hand side and move the total risk from the left-hand side to the right-hand side. Okay, here I would like you to take note. When you click on next, what do you see? Immediately you go to the result selection, saving this result selection. Okay, there's no other options available. So you just click on finish. Now, and you see that the result, that the total risk is way above the acceptance line. Okay, so now let's click risk and click on raw FN. Raw FN. So are we going to get the same curve as the smooth FN? Okay, so now if you click on next, you are able to choose the scenarios. And if you click on next, you are able to choose the effect type, And you click on next, okay. So you are able to choose on the, you are able to choose the scenarios and the effects. Okay, so the raw FN, it's also above the acceptance line, but you see that the different from smooth FN, the acceptance line didn't, it's not extended to 300. Now that's because in the risk, in the settings tab, in the risk preferences, and in the charts tab, we have only set the maximum number of fatalities to 10. Okay, while smooth FN will automatically extend the curve for us, okay, but raw FN will not do that for us. Okay, so now if I want to find out which are the scenarios, I'm just going to trial and error. Okay, I'm going to try and error and to see if I remove some of the scenarios from the result selection, am I able to push the curve down? And from the previous risk control results, I understand that the toxic risk is driving the risk to the west town, okay, to the west town. So especially chlorine storage. So I'm going to remove chlorine scenario from the results selection. So I do this by clicking at the risk button, and then I click at the raw FN, and then I choose total risk combination. And from here, I just want to be safe. I remove all the toxic ammonia scenarios, chlorine scenarios, and hydrogen sulfide scenarios. Then I click on finish. So it's still giving me the same curve. And that's because, okay, the population include of not just only people from West Town, but also on-site workers. So from the IR ranking grid, let's take a look at the control room, okay, and then the outdoor vulnerability. So the first, okay, that it tops the scenario that tops the risk contribution is the ethane line. So I'm going to try the ethane line. I'm going to try to remove the ethane line and see if it has any impact on the FN curve. Now this is a very useful function because you do not have to rerun, okay? You do not have to rerun the model again when you are doing the trial and error. So I'm going to remove the ethane line. So that's under utility. Where is utility? Yeah, here. So I'm going to remove the utility and just click on finish. There is no changes at all. So I'm going to remove more. So now I'm removing everything. I'm just leaving toxic risk. No, if I just want toxic risk, I can just show toxic risk. Okay, never mind. In the process of determining what contribute to such a high FN curve, let's look at the individual run rows. Oh, everything is above. So everything is above. Oops. I need to remove a lot of scenarios in order to get, yeah. I will need to remove a lot of scenarios in order to get a curve that is at the allowed region. So in this case, what I would do is, sorry, I clicked accidentally. So let me try again. I'm going to show only the results of one process unit. So maybe just isom, like naphtha feed, and then next, and finish. Okay, well, it has some small changes. Yeah, but we can see that all the scenarios actually contributed to high FN curve. Okay, but the useful function of raw FN curve is such that it allows you to filter out scenarios so that you can trial and error. In a very short time, you'll be able to find out which are the scenarios that contribute to the high FN, and you can try to remove these scenarios and see if by removing these scenarios, will you be able to get a FN curve that is in the ALAP region. Okay, let's move on to the SR ranking grid. I'm going to show the SR ranking grid. Okay, we expand the XR ranking grid. We have here the different scenarios, and then the coordinates, then the model frequency. Okay, we have the model frequency, then we have the average fatalities and the risk integral percentage. Okay, this is percentage, and risk integral. Okay, average fatalities, risk integral, and then the zero deaths. Okay, the average fatalities is being calculated by dividing the risk integral by the model frequency. So the average fatalities, it has the function of showing you what is how without considering the frequency, how severe or how many people can this scenario potentially kill. Okay, the worst case that we get is this scenario known as the light naphtha feed. Now, given its location that is close to either the on-site workers or the off-site population, it has, without considering the frequency, it has the potential of killing 13 people. So it is the worst case here. Now, but the risk integral is the results after considering the frequency. Okay. Then we have the zero deaths, 1, 10, 100, and close to 300. The maximum number of people killed is 300 people. And these are the corresponding frequencies to each of the number of people being killed. Okay. So this is SR ranking grid. And let's move on to look at the category PLL. So remember that we have categorized our population according to public or according to operators, maintenance, admin, or others. So if we click on category PLL and we move the total risk from the left-hand side to the right-hand side, then we click on finish. Okay, so when we expand here, we are able to see the PLL for each of the respective category, namely operators, process control, maintenance, admin, public, and other. Okay, then the PLL here is the total of everything. Okay, if you total up the PLL of all the categories, you will get this final number here. Okay. The next thing is you will be able to see what are the scenarios that contribute to the PLL of the operators, process control, maintenance, admin, public, and others. So we are able to see that the first scenario, the catastrophic rupture of an ammonia tank, it has the impact on the operators, but it has no impact on process control, maintenance, admin, and public. Okay, and then we have another scenario, which is the LPG export, the large release scenario of the LPG export. and it has impact on the operators, process control, and admin people and others, but it has no impact on the maintenance and public. So this category PLL provides you with the PLL of different worker groups, okay? And it also breaks down the scenario that contributes to the PLL of the different worker groups. So it's very convenient, and I hope this would give you the convenience of interpreting the results, and when you need to make some judgment very quickly, hopefully this will provide you with some useful information. Okay, so we have gone through the societal risk ranking grid and the category PLL. So we are coming to the quiz questions. So I hope by now you should be able to generate the smooth FN curve, the raw FN curve. I hope you should know how to filter the scenarios or select the scenarios to be included in the raw FN results. And then hope you will also be able to generate the SR ranking grid and the category PLL. So now when we move on to the quiz question, okay, is the societal risk acceptable according to FN curve? Okay. So if you look at how I operate the software just now, it's very clear. So does anybody have any doubts about this question? Okay, then we launch the poll now. Okay, so it's very clear from the results, whether it's smooth FN or raw FN just now, that the answer is no, because no matter how I choose to exclude some of the scenarios, the FN curve is still above there. Even if I choose one scenario, one process unit, it still drives the FN curve to be above the acceptance line. Okay, so the answer is no. And the next question is, what is the total PLL for all population per year? Now, this is for all population. Okay, it's not broken down according to category type. Okay. So does anybody have any doubts about how to get the answer? Okay, so we launch the poll now. Okay. And the answer is 0.13. Now, I have not closed my window yet, so if you come and look at the software screen on my screen, the answer is over here. PLL 0.131844. Okay. So let's move on to question number 10. Which population category has the highest PLL per year? Okay. Unfortunately, for this question, you will have to look horizontally and not vertically. You will have to look horizontally and to find out which number is the highest number. Okay. So let's start the poll now. Okay, let's take a look at the answer. The answer is B, operators. Now, there are more categories in the PLL report. So if you are, in this question, you just have to compare the PLL figures for 3 categories. That is process control, operators, and public. So let's take a look at the software screen. It's still the same screen. I've not changed the screen. So if you first look at the process control, now this is 2.68 E minus 3. And then let's take a look at operators. The operators is 0.119114. And then if we look at public, 1, 2, 3, 3 zeros, 3.9 E minus 4. So it's very clear that operators have the highest PLL. Okay. So by completing the 10 questions, we have no more quiz questions. Now, congratulations to everyone for finishing the quiz questions. Yes, we have some hiccups whereby somebody who cannot generate the results, and thus she's not able to answer the poll questions. So we will look into that.
I was able to do it for the last 3 or 4. The results did come out. It's only for the IR grid, the IR ranking grid and the IR ranking details. I just couldn't generate the table, but I could do it for the contours and the other stuff. The FNet curves was okay.
Okay, noted. And thank you for notifying us. Okay, so I have a last few more slides. So let's just go through the last slides, and then we can call it a day, and you can stay on to ask questions. Okay, basically this software has a very powerful tool, and it is called the risk results wizard. Basically, the risk results wizard is it allows you to choose different run rows or different combinations. It can generate the results according to the selection you have made, and then like for example the raw FN. When generating the raw FN, you are also able to filter out which are the scenarios that you do not want to include in the FN. That allows you to establish which scenario is contributing to the FN contributing to the FN. So you are able to, by targeting those scenarios, you are able to bring the risk down to acceptable range. So the risk result wizard, it allows you to filter out scenarios, the outcome type. The outcome type meaning that is it a continuous or is it a instantaneous release? Then is it an immediate or delayed ignition? Then is it a flash fire or a jet fire or an explosion? And then you can also choose the risk ranking points and the vulnerability type. So the risk result wizard allows you to choose these few things. Okay, once you have chosen all the items you want to include in your risk results view, the selection can be given a name and saved in the program, so that next time when you want to generate the same results, okay, you can directly go to the results super tab. Let me show you that. Okay, that is here. All your result selection can be saved under this results tab. And you do not need to go, if you name it correctly, or if you can remember the name and what are the steps that you have chosen for this result selection, then you can directly click here, and then it will give you the results directly without having to choose again. Okay, so let's go back to the slides. So the created selections are all saved on the Results tab for easy and quick access. The selections can also be renamed, deleted, duplicated, or edited. More risk results can be generated and viewed from the created selections. Now, once the level of risk is known, it is important to know which release cases are contributing to that level of risk. Risk ranking points can be placed on map. For each location, specify details of contributions to risk at the point from individual release is reported in an individual risk ranking report. These risk ranking reports allow you to identify the high risk contributions, the critical items on your site, which largely influence the risk at those specific locations. By knowing which equipment items and release scenarios pose the largest level of risk, the risk can be managed. To answer the question, what is the overall level of risk? We can look at individual risk contours and or FN curves showing societal risk results. To see which events are contributing to risk at specific locations, we can use risk ranking point results. To see which events are contributing most to the number of fatalities, we can look at societal risk ranking report. To see which population groups are the most exposed to risk, we can look at category PLL. Okay, we now come to study manager. So study manager is an application that is out of, I mean, it's not out, but it's an application that helps you to combine several Safeti studies together. Okay, so if let's say we have a very big plant and a few people has been assigned to do QRA for the big plant. So the work is divided among 5 people. So each of these 5 people created 5 models. Okay, these 5 models, okay, it's on certain process units. So let's say we have model A, B, C, D, E. So at the end, when we have completed the model for these 5 models, we use study manager to combine these 5 models together. Now, provided that these 5 models are using the same map and coordinates, then study manager will be able to combine these models together successfully. So just a very quick demonstration of study manager. So if you click on the magnifying glass of your Windows Start button and then just type in study manager, you have a study manager version 8.22. I'm using 8.23. Okay. Okay. Study Manager also have a very similar user interface than Safeti and FAST, okay, except that at the very beginning, you will need to import workspace, okay? So you need to import workspace. So by first clicking add, the add button, okay, then you will have this import workspace. Okay, so once the 5 colleagues have completed their 5 models and then run and with results, then they need to export their workspace. After they have exported their workspace, this is where we import the workspace. Okay. Now I do not have a case study for this, so it's just a very simple demonstration of how to use the software. And then let's say model A has 2 run rows and model B has 4 run rows. Okay, then Study Manager is able to combine them and generate an overall risk contour. In this case, because these 2 models are very far apart, one is over here, another one is over here, so you see 2 separate contours. Okay, last is help and support.
Richard, can I add? Yes. Richard, yeah. So the study manager is pretty useful. For example, if you are awarded a very large project for a big company, and you have different teams that are working on different plants, you can work separately. You can build your models in different files. You can use study manager to get a combined risk contours or FN curves, which is pretty useful. Yeah. Thanks.
Okay. So we come to the last part, that is help. Whenever you need help urgently, you can always go to the help button and then click on show help. In every data input window, there is also a help button. When you click on the help button, it will show you the relevant information for wind speed, for particle stability. So this will bring you directly to the relevant explanation notes. Whereas for this show help, you will still have to type in the the subject that you are looking for. Let's say, for example, explosion. And when you click on list topics, it will list down all the explanation notes that has the keyword explosion in it. Okay, we also have the technical documentation. This technical documentation lists down all the methodologies, all the formulas, equations, and the standards that we refer to in the process of building up this FAST and Safeti software. Okay, so the technical documentation has the basis of the basic fundamentals theory of the discharge, dispersion, risk calculation, everything. All of the technical documentation are protected by a password. The password is Palace House with P uppercase and H uppercase. So whenever you are in doubt or you would like to find out what is the basic theory of discharge or dispersion calculations, you can open one of these technical documents and read up. It also has the verification and validation information. Because we have done verification and validation for each of the calculations. Sorry, I should say for each of the calculation stage, meaning that the discharge, the dispersion, and then the effects, the jet fire, pool fire, the risk. So all this has been validated. What we have not done is validate this CO2 release for wind speed 2 meter per second, then 2.1 meter per second, then 2.2 meter per second, 2.3 meter per second. We have not done that. We have done, let's say, CO2 release for 2 meter per second. And is the results verified for CO2 for 5 meter per second? Then you will be able to find out the conditions and the condition which we verify and validate our calculations. Okay, lastly, we have made a lot of videos for your benefit. You can access these videos in this given HTML link. The videos show you how to do certain things. Okay, here we see that how to use Safeti to get a breakdown of risk into population categories. Okay, how to export FAST and Safeti results to Google Earth. How to export FAST and Safeti results to Google Earth Part 2. And yeah, you can download our latest software from the customer portal, and the link is www.dmvgl.com/cp. And you can also access our customer portal from this help tab here. There is a customer portal here. And whenever we launch our software, we will ask you to go to our customer portal and to download the latest software. You will need your username and password to access the customer portal. If you do not yet have a username and password, you will need to send us an email so that we can create a username and password for you. Okay, for customers with existing SLA, that means a maintenance agreement with us, you are entitled to global technical support. So basically, you send an email with your questions to software.support@dmvgl.com, and our technical support engineers who are located in Houston, London, Dubai, Kuala Lumpur, and Shanghai will answer your questions. Okay, I am located in Singapore because given my ability to work remotely, I'm also part of the technical support team, and I can support you from Singapore. Okay, lastly, we come to the review of the day. We look at the overview of the Safeti. we learn about what are the data input required for Safeti to make Safeti model works, to make Safeti model run. We learn about the study structure, the different run rows, how to set the different conditions for one run row to run the model. And then we learn about the risk theory. We have taken a look at the risk results, particularly the individual risk and the societal risk results. And lastly, I have also introduced you to the help and support. So if you have any questions, please drop us email. And it will take us some time to reply to your email because we receive questions from all over the world. But we do our best to answer your questions. Okay, more information for online trainings. There are more online trainings coming. On the 19th of August, there's a fast for dispersion. This is fast. And then 2nd of September, fast for fire and explosion. And then 22nd October, Safeti for pipeline. Then for face-to-face trainings, unfortunately, given the COVID-19 pandemic situation, we are not able to do face-to-face trainings for now. But we used to do a lot of classroom trainings all over the world. Yeah, and we also have the SA00 Fast Getting Started e-learning. Now, this e-learning consists of consists of videos. Okay, for you to get started with FAST. So it's a very basic, simple function of FAST. If you are interested, so you can click on this link to find out when is the next available e-learning session. Okay, if you need a software license, please drop our sales manager an email. Okay, so yeah, thank you all. I've managed to finish all the presentation slides. Okay, but I'm going to stay here until 5 o'clock for you to ask questions. If you are in a hurry to leave, you are free to go now. Yeah, I'm just sorry to hold you back because I overran by 37 minutes. We are supposed to end at 4 o'clock, but I thank you for all your cooperation to stay back and to and that we can finish this training.
Thank you, Richard. Richard, I had just had a question because we have the license valid for a few more days. Will you be sharing your PowerPoint slides at least? Because for those of us who are new to the QRA concept, we may need to refer to your slides to remember the terminology and to practice with the e-tutorial.
I would love to, but unfortunately, because these training slides are copyrighted, so we do have strict instructions from the management that we are not allowed to circulate the training materials.
Oh,
so
okay.
Sorry for that. Yeah.
Richard, I think there is a misunderstanding. So actually, we share the PDF version. We already
share the PDF version.
Yeah, we already shared. We already shared. It's if you go to if you go to your control panel of GoToWebinar, you will see handouts. You can actually see this PDF version is there.
Okay, so there are handouts.
Yeah, I also sent that yesterday to all of you. If you check your email, it should be there.
Okay, so we can just download it from there and practice, right?
Yeah, you
Since
can.
We have the.
Yes, so you will be able to use the software for for 1 more week to practice what you learned today.
Yeah, that's very useful.
Another thing, if you go to Help tab, there is a tutorial. You can also follow the tutorial, but of course, what you learned today is much more than tutorial. Yeah.
Yeah.
Todd, yeah. Just to clarify my understanding, all these participants today have a valid SLA with us?
I don't think so. No, not everybody.
Oh, okay.
Yep.
Not everybody. Okay. Yeah, but okay. I'm sorry that I'm mistaken with because I always have the we always have the instructions from the management that the presentation slides that we make for made for various presentation occasion not to be circulated unless approved by sales manager. So in this case, yeah, Todd has given the permission to share the handouts, so that so you have got the handouts. Yeah.
Yeah, we are happy to share the training materials. Yeah.
Todd and Richard, I have one question. This Safeti, what we have discussed is for specific to onshore. For offshore, the same software will be used, or a different module need to be used?
Okay, for offshore, it's better for you to use Safeti Offshore because yeah, we have another software known as the Safeti Offshore. So Safeti Offshore allows you to build 3D model of the offshore structure. So it's better to use that because for Safeti Onshore, as you can see from the results, it's at this point of time, it's 2D. That means it's a top view. That means you look at the results from the top. Now we are also developing the 3D function for this Safeti Onshore. But as of now, Safeti remains as a tool for onshore. Now, it's possible to use Safeti for offshore purposes, but you will have to sort of like, justify your results, like how for offshore, do we really want to see the contours? Because for offshore, we talk more about IRPA, not really risk contours.
Yeah. Okay.
Yeah.
My next question is, can I proceed?
Yeah, sure.
Yeah, I have just sent a Safeti Offshore link demo. It's a 10-minute demo to Safeti Offshore to the chat box. If you check the link, you will be able to see what Safeti Offshore can do for you. Yeah.
Yeah. Thanks, Todd. And my second question is, for an example, in-plant piping. For an example, I have a tank farm. From the tank farm, I am pumping one flammable fluid to my process unit. This is not the pipeline. This is the in-plant piping. So to do the risk modeling for that case, where can I place my release scenario? Because this is around some maybe some 20 meter to 50 meter piping.
Yeah, just to answer your question, the release point can be anywhere because it can be on the tank. It can also be on the pipe itself. So it can be any point. Yeah, as long as it is containing hazardous material, it has the possibility to leak. So you will have to use a scenario to represent the leak location, either leak at the tank or leak at the piping.
Okay.
Yeah.
Okay, perfect. Todd and Richard, my request is, since I have access to software for another some 4 to 5 days, I will go through it. If I come across any specific questions, can I drop a mail to you people? Is it possible to clarify?
Yes, please. You're welcome
Yes, of
to
course.
contact us.
You're welcome to send question to us.
Thanks a lot, Richard and Todd. I am leaving now. I have some other works to follow on. So we will meet again for the next training course. Thanks a lot. Thanks for the.
Yeah, thank you so much for staying back. I'm sorry to hold you back. I'm sorry.
No problem.
Richard and Todd, I'll be exiting the webinar as well. Thanks for the training.
Thanks,
Bye-bye.
Anu. Thanks. Have a good day.
Okay. You too. Bye-bye.
Thanks to you both. Definitely very valuable to get a bit of background in the program. I'm gonna sign off now. I don't have any questions. If I do, I'll send them through on an email separately.
Yes, please. Thank you very much.
Thank you. Bye.
Thanks, Richard and Todd. So since I'm already 5:44 here in Japan, so I'm going to log off now. Thank you for the training.
Thank you very much. Yeah, it's very late for you. Have a good evening.
Thank you so much. Sorry for holding you back.
Yeah, no problem. Thanks for the training. It was really useful. Thank you. Bye.
Hello.
Yes.
Hi, sorry, I just had a couple of questions before I left. I just wanted to confirm my understanding for the combination factor. So
Yes.
for example, when we had the run rows, we had 2 for flammable, which is for day and night. I just wanted to ask, what was the significance of assigning the values, the 0.4 and 0.6?
Yeah. So because the 2 run rows, they are running the same models repeatedly. So okay, the flammable day, they run it is running the models. Okay, the models that you select for that run row. Okay, it runs the model once. Then the next run row, flammable night, is running the model again. So at the end, the risk results, when you combine them, it's double counting. So we assign a factor of, it's double counting because the 2 run rows are running the same model repeatedly. So at the end, when you combine the results, it's double counting. So we assign a factor such that the risk results are multiplied with 0.4, 0.6. Because in this example, we are assuming that the nighttime is longer than daytime. In certain countries, during winter, the nighttime is longer than daytime. So it has a distribution factor of 0.4 and 0.6 for day and night respectively. And then, so in normal cases, we would assign 0.5 and 0.5.
I see. Okay, yeah, that makes a lot more sense. All right. Second question that I asked, and this might be a bit more specific. So there's a function in Safeti which we could specify the building height. Am I right to understand that, for example, if you have 2 buildings, building A and building B, right next to each other, with both buildings around the same height, let's say they're both 5 meters tall. If we have a dispersion from building A and the wind direction pushes it to building B, will building B actually impinge on that dispersion, therefore affecting its actual gas cloud size? Is that how building height works?
Not really. Okay, the building height is not intended for that function, but it can work along that way. Okay, let me clarify on the intention of having the building height. We have the building height for 3D explosion purpose. That is because when we need to calculate the volume of the building. Then when we are calculating the ingress of the flammable gas cloud or toxic gas cloud into the building, we consider the air change per hour of the building with the outside, so that if the release is inside the building, so would there be any release out of the building and continue to disperse downwind? Okay. So the air change per hour will make use of the volume of the building, and the volume of the building is also calculated from the area of the building multiplied by the height. So that is why we have the height of the building. Yeah. Then second thing is regarding your question of when I have a release inside a building, and then would it impinge or would it ingress into the next building? That actually has to be calculated, has to be analyzed, and then has to be interpreted from the results. And I have not really done this before, but I believe that the software can achieve it.
Okay. So impingement would technically, we would have to make kind of like make sense of the results to see whether or not it actually impinges. So the building height really is more used in indoor dispersion purposes. Yeah.
Yes, but when we talk about impinge, we normally refer to flame impingement, meaning that the jet fire, or the pool fire is the flame impinging on an equipment or the building. In terms of dispersion, so what you have is indoor dispersion, and then first it has to get out of the building. Then after it gets out of the building, what is the dilution? How much is how much it gets diluted, how much concentration of the gas is left, and then would it be going to the direction of the next building, and then is the next building a confined building, meaning that that means if the next building is positively pressurized, it also has a air change per hour. So would the gas ingress into that building?
Okay. Okay. Yep. No worries. Yep. Okay, that makes sense. Yep. Sorry. So that really last question.
No problem.
I know
You can ask questions.
I know Safeti uses congestion area as an input. Does FAST use congestion area? Just that.
Yeah. FAST and FAST 3D is able to calculate congestion. Is able to calculate explosion due to congestion for you.
Yeah, it's the same.
In FAST as well. So
yeah.
Sorry.
In FAST as well.
Yeah, it's the same.
I see.
You can also define a congested region in FAST, but you know FAST is a consequence tool, so it can only generate the effect contours. Sorry, the effect contours.
Calculations. The overpressure, the distance to overpressure.
Yeah.
Yeah. So would congestion area actually have a role in overpressures in FAST specifically? Because I know it works in Safeti. So since FAST only deals with consequences, will it actually have a effect on the results?
Yes, it has.
Okay.
Because the congestion, the volume of the congestion, not just the congestion area, but the volume of the congestion would directly affect the overpressure, the magnitude of the overpressure. So in FAST, it's also the same.
Magnitude. Okay.
Yeah, actually, in FAST, if you define congested area, you will be able to see the effect contours for example, for overpressure, which will take into account the congestion which you defined.
Okay.
Actually, in our FAST for fire and explosion training on the 2nd of September, we are going to cover this as well.
Okay. Easy. No worries. Okay. Yep. That's it from me. Thank you so much for your time and for your expertise. I really appreciate it.
Thank you very much, Akmal.
Thank you very much, and sorry for holding you back.
Yeah. No worries at all. Thank you. All right. Have a good day.
Thank you. Have a good evening. Bye-bye.
Bye-bye.
Hi, Richard and Todd. I got a question here.
Hi, Liang Hong. How are you?
Yeah, sure. Please.
Please go ahead. Fine. Yeah. So I understand under the global parameter tab, there's an event tree parameter, and then under the individual scenario created risk part, there is also some ignition probabilities.
Yes.
So if I already, let's say I selected UCOA and CLA ignition probability under the risk tab, how does it interact with the parameters, the event tree parameters in the global tab? Will it override or? Yes,
it will override. So in the immediate ignition probability, there's a selection for use event tree. If you really use event, if you choose that use event tree, then it will follow the event tree parameters. Okay. If you use CLA or UCOA, so what it will do is that it will replace the immediate ignition probability and delay ignition, or depends on what you choose for delay ignition. Okay. So if you use CLA and UCOA for both immediate ignition and delay ignition, so the event tree, the immediate ignition and delay ignition branch will be replaced by the probability that you that is calculated by CLA or UKOA.
Okay.
So that is the function of it.
Yes.
I see. Okay. Thank you.
Okay, we have Irene and we have our Taiwan colleague who didn't speak at all during the whole session.
Actually, I'm Irene. Actually, I cannot some of the. I mean, I cannot. Some of the exercise I cannot do it also. I need some time to practice because I quite new with this one. Yeah, maybe later if I have the question, I try to email.
Yeah, sure. You just email because the time constraint is we are running we are very short of time to complete what is supposed to be a 4 days training in just 1 day. So that's why I'm quite fast in doing the exercises.
Yeah, because I don't know is it the internet connection problems not because on some site there will be delay. It means like suddenly like when you're talking, then I cannot follow. I have to refer back the PDF file.
Oh, sorry about that. Sorry about that.
Maybe the connection or something. That's why sometimes I cannot follow up.
Yeah,
maybe. I just try to go through everything again.
In order to solve the internet connection problem, I actually have a router. I have a router specifically just inside my study room. Yeah. That is an additional router that I have in the living room, and then I have one more router inside the study room. Yeah, just to ensure that I do not, just to ensure that it's a smooth connection.
Because sometimes it's okay because sometimes when you're talking that is same with the slide with showing. Sometimes it's neither. That's why sometimes it's delay in the anyway, thanks for today. I have some ideas about the Safeti. Thank you very much.
Thank you, and sorry for holding you back.
It's okay. Thank you very much.
Yeah, Richard, I think we can close this webinar now.
Okay, let's stop, or rather, let's talk for about 5 to 10 minutes. You want can we stop the broadcast